The enumerate function, and we're going to travel back 2,000 years and imagine that we work at the ticket office at the Colosseum, and this weekend there's a big gladiator game going on, and we want to keep track of who gets in first. And right now there's a line of 5 people outside the Colosseum, 5 friends in fact. And we write their names down on, I guess, a piece of stone or something, and then we bring them back to put them into the computer. And let's not discuss the computer anymore, or how we get power for it. Let's just continue. So now the big dog, the Roman Pontius Pilate, shows up, and he wants a list of the people that are in line so we can see who gets in first. So we naturally know how to do that, so we say, for friend in friends, and then we'll print friend. Very happy with ourselves. There's our list. We give it to Pontius and we say, are you happy? And he says, no, I want them numbered. How do you want them numbered? Well, I want a number in front of each one of them. I want 1, 2, 3, 4, 5, 6, 7. Okay, so how are we going to do that? Our loop doesn't really help us with that. We don't have a number that we can use. Now, naturally, this is an old problem. And in most programming languages, you would solve it in this way. You would create an iterator called I, almost always. Set that to 0. And then we run the loop, and then we print the I with friend. And then we increase the I, so we set I gets I plus 1. Or, of course, the other notation, which can be plus equals 1, right? So if we run that, he gets his list. He's not terribly happy with it starting at 0. He wants it to start at 1. So we'll oblige, and we'll change the iterator start to 1, and then we'll run it again. Now, there's a list, and he's sort of happy, but he's thinking a bit. So while he's thinking, let's see how we could solve this in a more Pythonic way. It turns out that the nice people who created Python for us gave us a special function. It's called enumerate. So if we take this and copy it, and we say for friend in friends, but we use the function enumerate, like that. And then what we need to do is say for num. We could actually say I to make it exactly the same as the other one, but since it's Python, we're going to use nice things that we understand what they mean. So for num friend in enumerate friends, print num friend, and we don't need this incremental thing here. So let's run that. So first we have the old school loop, and then we have our own, starting with Brian. But it also starts at 0, so what do we do about that? Well, the nice people at Python have thought of us again. So there's actually an option to introduce a starting number. So let's start it at 1 and run it again. Now, as you see, they both look the same. So that's awesome, right? But now Pontius Pilate is coming back and he doesn't look too happy. He says, well, that list is nice, but I think they should go lower down on the list. Why is that, we say? Well, I have a few of my friends who'd like to come and they would like better seating. Right, so how many friends do you have? 5, 6? 50. Okay, so we'll change this number to 50. Actually, I guess we'll change it to 51, since all 50 of them probably want to get in or will be crucified. And then we change the iterator to 51. Run it again. Aha, so now we've solved Pontius' problem. Now let's look at what this function enumerate actually does. And we'll do that by copying this, and then I'm going to pretend that I'm the computer. So we're going to say eFriends, and this is our enumerated friends. So what it actually does is it goes in here, and it says, in this case, 51, comma. And then I'm not sure if it does a highlighting like this. It does that. Makes it into a tuple. Does the same thing with this, 52. Then it does this, 53, 54, and 55. And then, of course, we need to make them into tuples. So we'll do that quickly. So that's basically what the function does. It goes into the list, turns all the elements inside it into tuples, and puts a sequence number in front of them. So that, of course, is useful not only for printing, but if you want to modify a variable in this way and have a counter on it. So let's look at what it actually is. So let's say print the type of the enumerated friends, and we'll copy that and we'll turn it into a list. Let's comment out this code. We don't need it. We'll see that when we run enumerate, it actually turns into a separate class or data type called enumerate. And we see below that when we print it, we actually do get those tuples inside that list, which looks very much like the one we had up here, except the numbering isn't great because we don't have numbering on this one. So it starts from 0. So let's look at a couple of examples of what you can do with this. For instance, if we don't want to use this number or the sequence number, we copy that. And we say only for friend, and then we print only the friend. Then you see we print the separate tuples. If we were to do the same thing, but we enumerate the enumerated object, and we number that from -100. What's going to happen then? Then you see that we get a tuple with a tuple inside. And the first one has the sequence number minus 100, 99, 98, 97, 96. Those are increasing in size since they're negative. And then we have the other tuple with the other numbering inside. Now this isn't just for lists, of course. We can do this with tuples or with strings. With dictionaries and sets, not so much. Doesn't make sense there because they're not really sequences. Let's go back to this one and paste that and try with a string. So let's change this to Python. And we'll say for num, we'll keep that, and then we'll call this letter in enumerate Python 51, and we can actually use a keyword, which is start, equals to say 5. And then we print num and letter. What do you think that's going to result in? Exactly. It's going to give us 5, 6, 7, 8, 9, 10, and Python. So that was a short introduction to Enumerate, and I'm hoping you find some interesting things you can do with it. And I will see you next time. When we looked at lists and strings, we did some sorting, and by now you may have figured out that the results of the sorting isn't always clear, depending on if you use the sort method on the lists or if you use the sorted function. I thought I'd try and bring some clarity to this. So here we have a list, a dictionary, a tuple, and a string. We know that lists are mutable, so we can change them. That's why they have a sorting method. Dictionaries are a bit special, we'll get back to those, but they are also mutable. Tuples and strings are immutable, so they naturally don't have a sorting function because you can't change them at all. If you want to change them, you turn them into something new. So if you compare the method on the list item, sort, with the sorting function, you'll find that the sort method doesn't actually return anything. It just does the work of sorting. So it goes in and sorts the list. It doesn't return a new list, whereas the function sorted actually returns a new object that has been sorted. So let's take a look at what that actually means. So let's start by printing my list. We'll say this is the original. So let's run that. So that's the original my list, right? Now if we go ahead and sort this and try and print it using the sort method, what's going to happen? We get nothing. Print can't print anything because nothing is being delivered. However, we copy this and print the list again and call it new. So when we print the list again, we see a sorted version of the list. Even though we weren't able to print it, it has actually been sorted. Now the same is true if we use the reverse. We see that we get a none, and then the new list has been reversed. Not sorted in reverse order, but just reversed. Now let's take a look at the sorted function. So let's do this, sorted my list. And the parentheses. Now we see that the sorted function actually yields a new list down here. But we also see that the print of the my list is still the same as it was in the beginning. So this is actually a new list that we've created here. And it's actually the equivalent of doing the following. Copy that. We'll say my list 1 equals a sorted version of my list. And then we'll print my list 1. So that yields exactly the same thing, and what we're actually doing is creating this new object. We're just not naming it when we're printing. So let's get rid of this again. So let's take a look at what happens if we start printing some other things. Let's print a sorted version of my tuple. So now when we sort the tuple, we don't actually get a tuple. As you see here in the middle, we get a list. If we print my tuple, it's still the same thing that it was before. Let's try and do the same thing with the string. We have the Python string, and then we have the new Python, which are both the same. And then we have our new object, which again is a list with the individual letters sorted in order, in this case in ascending order. So let's move on to the dictionary. What happens if we sort a dictionary? So we have the dictionary on top, and in the middle we have the sorted version. So we see what we've actually managed to do is sort just the key values in ascending order. So that's all we get. We've lost a lot of information. There's some other ways we could approach that same thing. For instance, we could sort my dictionary items. If we run that, we now get the results of the dictionary, but we get them as tuples inside a list. And again, they've been sorted on the key, so the first element, so add, be, car, and dog. As we did when we called the dictionary without any method, we can call the values. Now we're going to get the values in ascending order. Just as we could with the sort method, we can sort in reverse. So we can say, comma, reverse equal to true. And if we do that, we'll get the values in reverse order. So the syntax on both of those functions are the same. So let's go back to the list. And instead of sorted, we can use the reversed. And when we run that, we get something called a reversed object. So if we want to take a look at what that looks like, we need to turn it into a list. Now we get a reversed object, which again does not sort in reverse order, it just flips the list around. Now as a last example, we'll show a special case with lists, and that's a slicing syntax where we can say my list : -1. What do you think that's going to yield? That does the same thing we just did. It reverses the list. So with that, we'll take a look at some ways you can use the key feature when you're sorting. So let's get a new list and then a list of lists. So the top list has some negative values in it. So if we sort it, we'll get them in the order that we would expect. But what if we wanted to sort them in absolute value order? Then we can use the key feature. So we can say key, and then we input the name of the function that we want to use. In this case, the absolute function. If we just do that, they will now be sorted in order of the number, regardless of whether it's a positive or negative number. So you can basically put any function inside this key and it can get kind of convoluted and complex. We'll try to cover this in a later tutorial. I'll give you an example of how you can actually sort something like a list of lists. So let's take the one we have here and we'll change to my list. So if we start by sorting that, we see what we get. The list of lists has been sorted by the first element, so what we have here, add, and then the others follow, so A, B, car, and dog. So if we want to use a key, we can say key gets, and now instead of a built-in function, we can define our own function using a lambda function. The lambda functions are throwaway functions that you can write on one line. They're really convenient, and we have a separate tutorial on them. So lambda, then we'll say item. So that's the item in the list that we're trying to sort. And then we write the actual command, which is item. So that's the list inside the list. And then we specify which index in the list we want to sort on. So if we want to sort on the same one we just did, we'll input 0. So if we run this, it sorts the same way. If we input 1, so that's the second index, run it. As you see, now it's the second element, the 1, 2, 3, and 4. If we sort it on 2, it now sorts on the last item, so 10, 24, 30, and 65. Hopefully that cleared some things up, and I'll talk to you next time. Let's talk about dictionaries in Python. Dictionaries store name-value pairs or key-value pairs. So they're a lot like ordinary dictionaries. You look up a word, that's the key, and then you get a definition or a translation, that's the value. So for instance, if you have short names for months like January, that's January. And then you would have Feb, which is February. Now that could be seen as a dictionary. It's sort of a translation table. So on the left, you have the key value, and on the right, you have the value. So let's get rid of that, and let's build a new movie dictionary. So we'll give the dictionary the name movie, and that will get curly brackets, move to the next line, and we will give it some input. So we'll start with the title. Separate by colon, Life of Brian. End with a comma. Next one is year, colon, 1979, comma, and then we have the cast. We'll make that into a list. So we've got John, Eric, Michael, George, and Terry. So now we've created the key value pairs. So we've got the key here on the left, title, year, and cast, and we've got the values on the right, Life of Brian, 1979, and the cast. And as you see, we have a string, a number, and a list. And we can actually use any data types. And we'll go down here, and we'll print movie. So now it prints the whole thing. Got the title, the year, and the cast. So what if we just want to print part of it? So for instance, just the title. Then we use the same kind of syntax that we use to get numbers from a list. So we'll say movie, and we'll write the string. So in this case, we want the title. That's the key. So we get Life of Brian. What if we ask for something that doesn't exist, like the budget? Then we're going to get an error. And sometimes you don't want errors in your return values. So to avoid that, we can use the get method, which we run on the dictionary. So we say movie.get, and then we specify what the name is. So in this case, we don't have budget. So what are we going to get back? Then we get back none, which is essentially an empty object, and that's sometimes more preferable. And what if we want to set a default value? Well, we can do that too with the get function. We can't when we're asking for it in the square bracket notation. So we can say budget, comma, not found. And now when we run it, we'll get a different answer. Not found. So we can specify what we're going to get by using a default value. Another thing we might want to do is update the dictionary. So how do you do that? Well, you can just specify what value you want to update, again with the square bracket notation. So we'll go down back here and we'll say movie. We'll change the title. So we'll set that equal to the Holy Grail. Then we want to move this. And we want to print something. So we want to print the new title, movie, get, title. Close parentheses, run it. Now we get the Holy Grail instead. And if we want to set something that doesn't exist, that can be done also. Go here, new line, and we set movie budget equals £250,000, and then we ask for the budget. We've now updated with a new entry in the dictionary. So if we print the whole dictionary, we've now added the budget to the end, over here. If we want to update the whole dictionary, we can do that as well with the update command. So let's try that. So we'll say movie.update, and we'll send in a dictionary. So that's curly brackets. We'll leave this and separate with a colon. Next we have year, colon, 1975. Then we have the cast, colon, and miraculously it's the same cast as before. Strictly speaking, we don't need to update it since it's already there. Then we close with a curly bracket and end the update command with the close parentheses. Now what do we get? Now we've updated the Holy Grail, 1975, and the same cast. Great. Other things we might want to do with the dictionary is delete entries from it. So let's try and do that. So one way to do it would be down here to delete. Use the del command. So we'll say delete movie year. That should delete the year. And then we'll see what happens when we print it. Now we see that the year is gone. A more often used and more useful way to remove values, while at the same time using the value in your code, is to use the pop command that we used for lists as well. And that's done in the following way. So let's specify a variable. We'll call that year. Gets movie.pop, and then we pop the year. Then we'll print year. So now we've printed the movie and underneath 1975. So we pop the value from the dictionary, so it's gone, but we saved it in a variable and now we have it printed. So you can also get some other data from the dictionaries, and we'll get rid of this first and this. So if we want the length of the dictionary, how many entries there are, we can ask for length. So we use the len command, same as in the lists. That gives us 3. We can also print the keys or the values, or both of them. So we can start by printing movie.keys. And that gives us the dictionary keys, title, year, and cast. We can print the values. So we've got those. We've got a string, a number, and a list. We can also ask for the items. As you see, the results now are actually tuples. So the title, Life of Brian, year 1979, and cast with its string are each tuples. Now another thing that you often do is that you want to loop through all the items in a dictionary. And it looks like this. For key in movie, and then we're going to print a key. If we run that, we get the title, year, and the cast. But we want both. So in order to get both of them, we need to extend up here and use both the key and the value. And we need to use the movie.items. So for key value in movie.items, and then we're going to print the key and the value. So there you see, now we have the title, Life of Brian, year 1979, and the cast with the names. And this is the for loop that you'll probably use a lot when you're working with dictionaries. And with that, I'll leave you for this time. See you soon. Welcome back. We're going to do some more with dictionaries. So here's where we finished, and let's paste in some new dictionaries. Here we go. Here are 3 dictionaries with people and ages. And these are just ages that I'm assuming that these people have had at some point in their life. In the case of Brian down here, that's, I think, about as old as he got. So like sets, dictionaries aren't ordered, and they also can't contain duplicate values, at least of the keys. They can, of course, contain duplicate values. So no duplicate keys, like there can only be one Arthur in the Holy Grail dictionary, but there can be multiple values that hold the value 40. That's not a problem. And like sets, membership tests are really quick. So let's look at doing a membership test. So how do we do that? Well, let's say we're going to print if Arthur is in Holy Grail. And that should give us a true if he is. So let's see if he is. He isn't. Now why is that? Well, it's pretty simple. It's because it's case sensitive. So if we make it Arthur with a capital A, voila, it becomes true. That's important to remember. All right, let's do something more interesting. If is not in Python, then we're going to print a message. So we'll say print he's not here. As you see, this didn't work too well because we now have an apostrophe that's actually a quotation mark. So we need to do something about that. How about we escape that character? There we go. Now it works. So if Arthur is not a part of Python, which he isn't, it should print he's not here, like that. And he's not here. Great. But if we asked if he was in Python, it would print true, and then it would print nothing because the if statement is not going to execute this print line, right? So we'll go back to that. Now let's look at concatenating or putting several dictionaries together. How can we go about doing that? Well, there are 3 different ways I thought I'd show. So we'll start with creating a few dictionaries. So we'll call them people. So people gets an empty dictionary. We'll copy that, create another one, and another one. We'll call this one number 1, and we'll call this one number 2. So our first method is the update method. This allows you to take one dictionary and add another one to it. So we'll say people, update, and then we'll update it with the dictionary Python. And then we will print people. See what happens there. So we've now printed the dictionary at the bottom here. And we see that it's only the Python one. Now, if we wanted to add all of these dictionaries together, we could copy the same code again, or mostly, like that, except this time the people dictionary now already has Python, so let's add Holy Grail. And then if we print it this time, it now has more. Now it has the characters from Holy Grail as well. And if we do it again, we can add the Life of Brian cast, like so, and print that. And now we get all of the ones from all of the dictionaries. So that's awesome, right? So that's one way of doing this. So let's look at number 2. A comprehension. So in this case, we'll say for groups in, and then we'll choose Python and Holy Grail as a start. Then a colon, and then we will say people 1 update with groups. So that means it's going to take what we're calling groups. So that's actually first it's going to be Python, then it's going to be Holy Grail. So it's using the same code, it's just doing it in comprehension. So first it's updating with the Python, then the Holy Grail. And then if we print that, like this, we'll see that now we get a print that only contains part of what we had before. So that's not the cast of Life of Brian. We need to add that as well. So let's do that. Life of Brian, run it again. Now we see that we have exactly the same result again. Now as our last version, we'll run method 3, unpacking. And that works in Python 3.5 and later. Okay, so if you have an older Python, not going to work, or at least not very well. So in this case, we have people 2, and that gets double star. That's the unpacking key. Python, then a double star. Holy Grail, double star. Life of Brian. And then we'll print people 2. Now let's see if we get the same result. Let's take a look at this, and it turns out we get the same result, but it's not sorted in the same way. Now, I'm actually not sure why it's not sorted in the same way, so I can't give you a good answer to this. But we know that dictionaries are inherently not sorted or ordered, so let's do something about it. Let's sort them to make it easy. So we'll do sorted. We'll do the same thing here, and the same thing on the last one. Now when we run it, now we only get the keys, which is not really what we wanted. We want the items as well, but at least now they're ordered in the same way, right? So let's add the items. Copy this. After we add a dot, here we go, put that there, that here, Now we run it, and voila, we get the result we were looking for. The last thing that we might want to do is sometimes we want to find the sum of all of the values that we have. So perhaps it's a shopping cart and we want to add all the numbers together. So the way to do that, if we print, write a text, say sum of the ages is something, and then we write sum people values. We look at the bottom here, we see the sum of the ages is 531. So that's how you sum over a dictionary in this case. However, if we make one of these numbers a string, it's going to crash. So let's run it again. So we get the list, but when we come down here to the sum, it's not going to work. So be careful about the values that you have inside. So which one of these methods to put the dictionaries together should you use? Well, if you just have two dictionaries, a regular update works fine. You just take the original one. We didn't have to create a new one called people. We could have used Python and added the Holy Grail to it, and we would have been done. If we want to do more than two, then using the Comprehensions works really well, because that's only one line of code. And so does the unpacking. That works well as well, if you're over 3.5. So I hope that was useful, and I'll see you in the exercise soon. All right, let's do an exercise on dictionaries in the form of a fantastic adventure game. Well, maybe it's not even a game. The instructions are up here, and we have a slide which tells us the instructions as well. So for our first version, and for the other ones, the background is the following. Our village is being attacked by a Germanic tribe. Those are dangerous. And you need to run to the store and get some stuff to help us save the day, and probably some girl or boy that we want to marry. All the prices that we see are in gold pieces, excluding VAT, because let's face it, back in the old days, VAT hadn't been invented. So hurry up, the Germans are coming. The first version that we're going to build now, the code should allow us to get one thing from each store. So if we have several stores, that's probably a for loop working there somewhere. And each item you get should be removed from the store inventory, and then do the same for the next store. One way to buy would be by typing the key newt, for instance, in an input box. At the end, we should print the items that we've taken or bought. In this version, we don't have to worry about paying for stuff or adding it up, so that's great. We'll hit the other versions in later casts, and we'll start with this one. If you want to do these as well, 1.2, 1.4, 1.5, you're welcome to it. But otherwise, we'll finish those in some other casts. So let's get cracking and take a look at what we can do. So the code instructions are up here, and I've added the three shops: the freelancing shop in form of a dictionary, the antiques shop. First, we have a name that doesn't have a price, right? And then we have the same thing in the antiques shop, and the same thing in the pet shop. Then we have the stuff that you can actually buy. So you can buy or rent, I guess, Brian, the Black Knight, Bickus Dickus, and the Grim Reaper, and a minstrel. If you're wondering what a minstrel is, it's a performer from the medieval times. And the reason it's negative is probably because they weren't very good very often. Then from the antique shop, we can buy a French castle, a wooden grail, a scythe, which is a sickle, which is what the Grim Reaper normally carries, a catapult, or a German joke on a piece of paper, whatever that is. Then in the pet shop, we can buy a blue parrot, a white fluffy rabbit, or a newt. And a newt is a small lizard. Right. So if you want to, you can either just start writing the code here, or you can extend the code that I have down here, which is what I'm going to be doing later. I have some instructions here. The ones that are capitalized are basically where you need to type and change some code, and maybe add some other stuff that you want to. So get cracking, and I'll be back in a little bit to show you one way to do this. All right, I hope you gave that a shot, and I'm sure it worked awesomely. If you didn't, give it a shot, and then come back. I'll still be here. I'm waiting. All right, I'm here. So let's take a stab at this. So we start with a cart. Then we're going to loop through our stores or dictionaries. So first, I'm going to remove this, bring it up closer. So we need to loop over our three shops or our three dictionaries. So that's three of those. Let's loop over just two of them to make it easy in the beginning, and then we'll add the third one at the end. For shop in, what are they in? We'll do a parentheses. We'll say freelancers and antiques. Now, if you want to stop at any time and continue the code from where I am, you're free to do that as well, of course. So let's get rid of this. There we go. So there's our for loop. And then we have our buy item. So this is the item that we're buying from the store. So it says input and f-string welcome to, and then the name of the shop. Those are the ones that I put up here. Name freelancing shop, name antique shop, name pet shop. So we need to input one of those. So the way we could write that, that's just getting the value from a dictionary. We've learned how to do that, right? So we could say antique, and then square bracket, and then put the name of what we want, which is name, right? Except we don't want the antiques name every time, right? We want what we've called it in this for loop, shop. So let's change antiques for shop. And then it asks us, what do we want to buy? Well, we would like to buy something that they have in the store. What do they have in the store? Well, that's actually just the dictionary. So here we just input the name, again, antiques. That will give us just the antiques all the time. That's not what we want. So we'll do shop again. So that should give us an input box that gives us some information about what we can buy and allows us to type in what we want to buy. Then we need to update the cart. And then what we'd like to do is make it lowercase because people can't type. And then look at that, it's all blue. We need a end of that F string. So there we go. Then we're going to update our cart with the contents of what we just bought. We need to create something into our cart, which is going to be a dictionary. So we're going to insert a key val, and our key val is that text that we just got. So that's by item. That's a string, and that string is going to give us some form of value. From what dictionary? Well, again, we could write antique, but we're not going to do that because we're going to write shop. And then what we want to do is what? We want to remove the item, remember? It should be gone from the inventory. So we're going to pop it. What are we going to pop? Well, here's where we need to enter the key value, which is the one we typed earlier in this row. So by item. Because that's a variable name, we don't need the quotation marks, right? So that's all well and good. And then the print statement is going to tell us what we purchased. What did we purchase? Well, we just purchased the cart, right? And we've added some stuff to that cart because we've been updating each time in the for loop here, cart update. So the first time it's going to give us whatever we bought from the freelancing thing. Then the second time it's going to give us what we bought from the antiques store. So we're going to put the cart here and say cart. And what do we want from the cart? We want just the keys. So those are the names of the items. And with a bit of luck, this should run. Let's try it. So I get a pop-up. I'm going to buy Brian. Let's not worry about what they do at the moment. And then I'm going to buy a catapult. So there we go. You purchased Dict Keys Brian Catapult. Today it is all free. Have a nice day of mayhem. So that was almost nice, except I don't like this formatting. Dict Keys, not very good. Let's say that was a receipt. We don't want that kind of information on the receipt. Let's try and make that into a list. Let's say list and see if that makes it any nicer. So we'll run it again. So I'm going to buy the minstrel this time. And then I'm going to buy a scythe. So this time we purchased minstrel scythe. Today it's all free. I kind of like it, but it's inside a list. I'd like it to be just normal text. So how do we do that? Well, we've learned how to join lists into text before. So let's do that. So what's the syntax for that? Quotation marks, and then whatever we want to split with, I want to split with a comma, and then a space afterwards. And then there's a dot, and then we have the list, which we need to join. Parentheses, close parentheses, close parentheses. Let's try that. So I'm going to buy the Grim Reaper. That's death. That should be good. And then we're going to buy a scythe for him. That's a sickle. That's what the Grim Reaper uses. So now we purchased the Grim Reaper and scythe. Today it's all free. Have a nice day of mayhem. Well, that's awesome. I'd like to enter a period there. And then as good form, you should probably not make calculations like this and format stuff in your final print string. So let's move that outside of this print string. So we'll take all of this text and call it something instead and make a variable out of it. So we'll cut that and let's put it here. Let's call it the items we've bought. So buy items, and we'll say that that gets the thing that we just had there. So this thing. And then let's put buy items in here. And then let's also add our pet shop up here. So now we're really going to buy from all the stores. So let's give this a shot. First store, I'm going to buy the Grim Reaper. Then I'm going to buy a scythe for him again. And then what do we buy? Well, the blue parrot from Monty Python tends to be dead, if you've seen that sketch. So let's buy him a blue parrot to keep him company. That should make him happy. You purchased Grim Reaper, scythe, blue parrot. Today it's all free. Have a nice day of mayhem. So I think we'll win this war. That's awesome. So I'll see you in the next cast where we can talk about future versions of this adventure game. Okay, it's time for version 1.2 of our exercise. Let's take a look at it. So we need to add the ability to exit the store if we type exit, or if we try and buy or type a non-existent item. We also need to add a purse with 1,000 gold pieces, and then fix all the payment things so that we can see how much we bought for, how much we paid, how much we got back, those kind of informations that might be interesting on a receipt, for instance. So let's start there, and you have a crack at that, and I'll be back with one way to solve it. There are obviously many ways, but this is sort of going to be a slightly dictionary-centric way to solve this. Go ahead, I'll be back in a sec. All right, did you try that? I hope you did. Otherwise, go back and do it. You done? Great. Let's take a look at this. The first thing I thought we'd try and handle is this part about exiting, if they type exit or if they buy something that doesn't exist. So that's the for loop we're talking about. We're inside a store, and we want to leave the store without buying anything, or leave the store if they buy something that actually doesn't exist, right? What we need to do is enter some if statements. First, a comment. There we go. So if the buy item, so that's the string text that is entered by the user, if that's equal to, so not gets, but equal to, exit, colon, then we're going to do something. What are we going to do? Well, we're going to continue. I jump to the next iteration of the loop, so just leave the store. So we'll go to the next shop, okay? The other part is if they buy something that doesn't exist. So in this case, it'll be if the buy item, we need to do a membership test and see if the buy item is actually inside the dictionary. So if it's not in, the dictionary, and the dictionary is shop, we need to do something. Same thing, continue. Great, so we're done. That should make us exit and should handle any case where we buy an item that doesn't exist. Let's try it out. Running the code. First store, I buy a minstrel. Second store, I type exit. Third store, I buy a cow, which doesn't exist. So as you see, the only thing we purchased was the minstrel. The other ones didn't even show up. So it looks like that code runs well. The second thing we want to do is create a purse with 1,000 gold pieces. So let's do that. And we'll call it purse. Why make things more difficult than they need to be? And that gets 1,000. So it's just an integer. So that's great. Then we need to calculate the price somewhere, probably down here in the print statement. Just before we do that, let's add some information for the user up here. Type exit to exit store. That should do it, right? So down here in the print statement. Today it's all free. Unfortunately, it's not free anymore. We have to start paying for stuff. So let's say your total is, and then we need some kind of variable there. Let's just say we don't know what the variable is yet, so we'll just have an empty variable there. Gold pieces. Then we want some change. Again, an empty variable. There we go. So let's take the first one. Your total is, what is the total space there? Well, we want to sum all the stuff that we have in the cart. And we have the values up here, right? We've been updating this cart. So we've got the buy items and the values of them. So let's just say sum and the values. Then we copy that. And in the second one, we need to calculate what our change is. So our change is the amount of money we gave them. Let's say we gave them 1,000 gold pieces and we need some change back. So that's going to be whatever we gave them, the purse, 1,000, minus that total amount of stuff that we purchased for. So that's that same formula. Now with a bit of luck, that should work. Let's run it again. Purchasing Grim Reaper, also purchasing a catapult. And then we'll purchase a white rabbit. Purchased Grim Reaper, Catapult, White Rabbit. Your total is 580 GP. Your change is 420 GP. Great. Seems like it's calculating correctly because 1,000 minus 580 is indeed 420. Perfect. Except we're using this sum down here twice. That's not optimal. So let's take that sum and let's create a variable for it. Let's call it total sum. And that gets that formula. And then we just replace this text with total sum. Copy it, paste that in there, and that's going to run. Now, while we're on that subject, I'd like to change this text here in the beginning so that it displays not only the names, but also how much they cost. And we're going to do that by creating a string, and then reusing that string and adding to the string in this for loop. So each time we buy an item, we add it to the string. So to make life easier, let's start by creating that string. So we'll call it buy items 1, and we'll just give it the empty string as the input. That's just to initialize the string. Then we need to grab some values for it. We need to do that before we pop the values here, because otherwise we can't access stuff from the original dictionaries, right? Because when we pop them, they're gone, and we actually want the one that's being popped. So let's do that here. Update the string. ByItems1 gets, and we'll start out with an empty ByItems1, because that's what it's going to be on the first iteration. And then we'll concatenate that with something that we've just created. So the first time we come through this, we have a ByItem, right? And that's what we want to add. So let's add an f string, f, and we have a variable. And that variable is just the string ByItem. So the ByItem, that's the Scythe or Grim Reaper or Brian or something. Then a colon, just to make it look more like a dictionary, but it's really not. Then in the second part, we'll put the value, so how much that item cost. So to do that, we need to access it from the dictionary. So the shop, square bracket notation, and it's the ByItem, because that's the text that they input. And then the price in GP, a comma, and a space to make things look nice. Then we'll go down here and copy this so that we can compare our results. And we'll just add a 1 here, using our new variable instead. So let's see if that works. Running the code, let's buy the Grim Reaper, and then let's buy a Scythe for him again. And the blue parrot as his trusty dead companion. So now you see we have exactly the same text, except the second one has more information. Grim Reaper 500 gold pieces, Scythe 150 gold pieces, blue parrot 10 gold pieces. So that's great. Now we've handled things so far. Now it's time for 1.5. Print inventory before and after purchases as one department. So basically, bring all the store inventory together and then print it before to satisfy the big business from the big city, and then after we've purchased the stuff to show that the pop actually worked, and also to keep inventory management flowing. So how do we do that? Well, we need to do something at the end of all the code and something at the beginning of the code. So that's the beginning of the day. Let's say this is the beginning of the day. So let's call it morning inventory. Department store gets an empty dictionary. That's just to initialize it. And then we're going to use this dictionary comprehension to create the department store. So for freelancers, antiques, and pet shop, we're going to update the department store with the department. We'll print morning inventory of stores, and we'll sort these. So sorted the items like so. And then to separate the text, we'll do an extra print line like that. We'll copy this for later use, go to the end, and then we'll get the evening inventory. The department store after is a new variable, which we'll get. So we'll use a different notation this time. Freelancers, antiques, and pet shop. And again, needs to be after Python 3.5. We'll paste in what we borrowed from there, move this last one to here. We'll run the code again. Oops, forgot to make that into a string. And the same here, of course. Now we can run it, except we need to change the department store to the department store after and run that. So let's buy Grim Reaper, let's buy him a French castle, and let's buy a white rabbit. Now, as you see, we first get a morning inventory print, which contains one aspect which is not really that useful, and that's the name. But notice that the shop is only there once. That's because the other two have been removed, because it can't contain duplicate keys. So we've got name and pet shop. That's not really inventory, is it? So we want to get rid of that. We'll do that in a second. Then in the morning inventory down here, which should be evening inventory, we'll change that. As you see, we have a white rabbit in the top one, but the white rabbit is gone, so our popping has worked. That's good. And we've sent a correct inventory, except we need to change the text. So let's do that. There, evening inventory. Now let's look at how to actually solve this problem. The thing that we want to do here is get something that will help us beat this Germanic tribe. And we've been buying the Grim Reaper with the Scythe and giving him a blue parrot, and that makes sense. But that costs quite a bit of money. Is there a different way to do this? Well, if you know Python lore, you'll know that This white rabbit here is in fact the white rabbit or rabbit of Carbanog, which is a lethal rabbit which will kill everyone who doesn't have armor. And since they're Germans, this brings us to another sketch, which is the one about the German joke, the one that kills anyone that listens to it. Since the people reading it don't know German, they can read the joke and all the Germans attacking will die. So let's try that after we've removed the name of our store. So let's go out here before our print and we'll say department store, pop, the name. So that should remove that. We'll do the same thing at the end. Department store after, pop, name. Now let's run it. So in this first one, we'll buy the minstrel, which we're going to get paid for. So that's awesome. The second one, we're going to buy the German joke. The third one, we're going to buy the white fluffy rabbit. Now we see the morning inventory no longer has the name of the store. We purchased the minstrel, German joke, and white rabbit. And we actually made money. So our total is minus 5 GP. So our change is 1,005 GP. So we have more money now than we did before. We've saved the village. Everybody's happy. That was a bit long, but I hope you enjoyed it. I'll see you in the next cast. Now we're going to talk about error handling in Python. When you're running code, sometimes you encounter errors and your code crashes. Now, sometimes that's because something you did, and sometimes it's because something happens on the outside of the code. Maybe it receives bad input, or maybe some part crashes, or you can't access a server, or whatever the case might be. When this happens, it's usually a bad idea to crash your program, because other things might be dependent on it. There might be a file open that crashes, and then you lose all the contents of the file if you're unlucky. That's why we have try except blocks, and they are structured in the following 4 steps. First, you have a try, which is the first part of the code. That's where you put the code that you'd like to run. Then you have the except part, which is executed whenever you run into some type of error. Then you have the else part, which is where you put the code that you want to execute if everything goes well. And then finally, you have code that will always run. So that's a good place to clean up after yourself, close any couplings you have to any databases or files or anything else. And this is the actual structure. Now I'll leave this here so that you can reference it. We're going to start with the 2 top parts, try and accept, because those are the main ones that you need to use. And then we'll go into the last bits. And then at the end, we'll talk about raising exceptions. So let's start with a piece of code. So here's some code that takes in a number from a user, takes 30 and divides it by that number, and then prints out a message. So let's run that and see what happens. So I get a box where I'm asked to input a number. I'll input 5. 30 divided by 5 is 6. Thank you for playing. So that's how that works. Now, what could possibly go wrong with this thing? Well, let's try. Let's try and input something that's not a number. Let's try and input a string. So I'll input 2 letters. Then we get an error. That's no good. What can we do to handle this situation so our whole program doesn't crash whenever we take in a string? Well, we can use the try. So we'll say try, colon, put that inside the try, this inside the try, and then we use the accept statement. So accept, and when accept happens, we will print an error message and say invalid input. We run it again. We enter 2 letters. Now our program doesn't crash. It doesn't give us an answer, but it doesn't crash. Now we get the string invalid input as our output. So how can we improve on this? Well, we could specify the error that we're getting. So in this case, we won't just do a general exception. We'll do an extra line. We'll do an exception, except something called value error. And an example of a value error is what we just had. So it's the wrong type of value that we're expecting. And we're expecting an int because we've got int here and we received a string. So accept value error. And if we get one of those, we will print bad value. We run it again. Now we get bad value. And the reason we get bad value is because the exceptions run from top to bottom. So anytime it hits an exception, it stops looking for more of them. So it's only going to give you one at a time. So this is a way you can sort of roll through your program and pick up error after error, which can be frustrating. So there we go. To further improve this, maybe we want to handle the specific case when somebody enters a 0 and we try to divide by 0, which is no good. So let's enter that as well. Say accept something called 0 division error. And when that happens, we'll print you can't divide by 0. Run this, enter 0, and you get you can't divide by 0. Now we can improve the readability of the message by adding a keyword here, as. That way we can specify the actual error that we're getting. So specify that as error, and then we'll put that in the print statement. So we'll say error. Say that here as well. Run it. Now let's try with a string. Invalid literal for int with base 10, LL, bad value. Okay, so that's the second exception. What if we run it again and enter a 0? This time we get division by 0. You can't divide by 0. And if we get some other kind of error, we'll get down here to the invalid input. Okay, and now if we look at the rest of the try except blocks, the else and the finally, how do we use those? Well, under the except, let's start with the else. So this is the command that we would like to run when everything goes smoothly, so everything works. And that's actually this print statement up here, right? So we'll take that and we'll put it inside the else block. And then finally is where we put the code that always runs. And that's this code. And that should complete our statement. So let's run that and see what happens. So we'll start with entering a number, 5. And it got printed double because we don't need this line up here, although we need to still calculate the number. Otherwise we won't get a division by 0. We'll say num1 gets 30 divided by num. We'll run it. We'll enter 0. Division by 0. We'll run it again. We'll enter a string, get an invalid literal. And now let's say that we want to extend this program so that we only accept numbers between 1 and 30. So enter a number between 1 and 30. Now we're going to use an if statement. So we'll say if num greater than 30, colon, we will raise value error of num. So if this happens, we'll raise the value error down here, and then we'll also put in the number here. So we'll say num. We'll extend this by saying not between 1 and 30. Let's try it. We know the other parts work, so now let's try a number of 35. Ooh, 35, bad value, not between 1 and 30. Will it work for normal values? 20? 30 divided by 20 is 1.5. So that's an introduction to try, except, and handling exceptions in your Python code. Speak to you soon. So earlier we looked at different data types like strings, numbers, booleans, and even more complex ones like lists, dictionaries, and so on. But sometimes you need even more than that. Sometimes you need more special data types to describe something, like maybe a car, a shoe, or a movie, or a student. A class is a custom-made data type that allows you to do that. You can say that classes are a representation of the abstract concept of something, like a blueprint. And then when you actually make something out of those blueprints, you are creating objects. So that's the real version of something. So for instance, the concept of a movie could be a class, and the actual movie, Life of Brian, could be an object of that class. Then when we create classes, they have variables, which we call attributes, and functions inside, which we call methods. So I'll paste that in here. Classes are blueprints, objects are the actual things you build, and then variables are called attributes, and functions are called methods. So with that, let's get cracking on creating a class. So to start, we write the keyword class, and then when we name classes, we use capitalization. So if we create a class called new cars, we would use camel casing. So every new word starts with a capital letter. In this case, we're going to create a movie class. So we'll call that movie. Now everything we indent is going to be part of this class. The first thing we're going to do is give it some variables, which are then called attributes. And we give it those attributes when we actually create the function, when it's born. We do that with an initialization statement, which is the action that creates the object. So def, 2 underscores, init, which is short for initialize, keyword self. So what kind of variables or attributes do we want the movie to have? Probably a title, a year it was made, maybe the IMDb score, and whether or not we've seen it. So have seen. Finish with a colon. And now when we name these, we need to start using the keyword self, and I'll explain what that is in a second. So self.title equals title, self.year, self.imdb score, self have seen equals have seen. Now the keyword self refers to the object that we're creating. So in the class, when we create this new object, that is the self. So you could call that anything, but convention is to use the word self so that everyone knows what it means. You could call it Joe or whatever you want, but don't is my recommendation. So let's start with that and see how we can access some information about this object that we are now going to create. So to create the object, we use the same kind of syntax that we've used before. So we call movie, and then we call it with the parameters that we have. So we'll call it with a title, a year, a score, and whether or not we've seen it. Brian, 1979, 8.1 in score, and true. And we'll call this film 1. Now, as an equivalent, you could view this as if we were creating a list. So think of if we were saying message, and we say, hi, how are you? Here we're creating a list and populating it with one object. And above, we're creating one film. We're using the movie to tell it to create an object of the class movie. Let's create another one. Let's create a film 2 as well. Copy that. Holy Grail, 75.2, and true. This is not film 1, but this is now film 2. And then we might want to get some information from this. So let's print some information. Let's print film, title of film 1, and film 1's IMDb score. So it's printed Life of Brian, and 8.1 is the score. Now let's create a function inside the movie class, and so we can use that as well. So we'll go back up here, and we'll create a print function. So define nice print. And that takes in one argument, self. And that'll be interesting in a second. I'll explain why. Colon. So what this function will do is print a nice layout of all the details of the movie. I'll paste in some text here. There we go. So we start out with printing the title, and then we use self.title because we're actually referring to the title of the object that we've just created. Then the year of production, self.year, then self.imdb score, and then self.haveseen. Now we'll call this function to print it. So we'll say film2 using the method of that class, nice print. So if we run that, so we get that. Let's comment out this row for a second. So there we go. We have the title, year of production, and the IMDb score. As you see, this doesn't take an argument, and that's because it's run on film 2. So the argument is implicit in that call because it's done from that object. Now this would be equivalent to writing the following: movie dot nice print, and then specifying the film we're getting this information on. So if we run that, we will get exactly the same result. We now get it twice. That's how self works. It's always a reference to the object that's active at the moment. Now you might want to create a database of these movies, and we could do that using a list. So we could create something called films and set it equal to film 1, and then film 2. And then we could, of course, print information from that. So we could print films 1 title and films 0 the title. And of course, we could use the internal method as well, saying films 0 nice print, and that would print everything of that referenced object. So at the top, we have the Holy Grail, Life of Brian, and then we have the nice print of the film's index 0. And that's an introduction to classes and objects. See you next time. Now let's talk about inheritance in Python and in most programming languages for that matter. So inheritance is when you have a class, say for instance a car, and then you have another class which will inherit the attributes and methods of that car class. So for instance, a car might be able to drive forward, turn, and brake. And if you were building a sports car, that would be able to do all the things that a normal car can do, but it will also be able to drive really, really quickly, or have really, really expensive repair jobs. And those methods could be special to that class, but it will reuse the same methods as the original car class. So we'll do an example and imagine that we're creating a game. And in the game, there are a bunch of characters. So we'll start with the first basic character type, a person. So the person in this game has a method move, When it does that, it moves 4 paces. It also has a rest method, and when it does that, it gains 4 health points. So in order to use this, we might say character 1 equals person, then character 1 move. So if we run that, we get that the person moves 4 paces. Now if we want to add some more characters to this game, we could do that. So let's create another class, and we'll call this class Doctor. So we'll have a doctor in the game. And the doctor does all the things that the person does, except he's also able to heal and help people get better. So one way we could do this is create the doctor class by copying all the information that's inside the person. But that seems unnecessary, and that's what inheritance is really good at solving. So the way we could handle this instead is simply to say, using the following syntax, that it inherits from person. So that means doctor is a person. So it has all the things that the person has, and then it might have some more. So if we don't have anything more, we could use the command pass, which simply means Python will skip the empty code and a doctor will be identical with a person. But let's create that extra method. So define heal self. He does that. He heals 10 health points. Now, instead of creating a person, let's create a doctor. And he'll move again. Got the colon. Let's run it again. He's still moving 4 paces, but now let's have him do something different. Let's have him heal. So he heals 10 health points. So that's great. He can do all the things that the person can do, and he can also do the heal. So let's add another character to the game, a fighter. And he can also do all the things that a person can do. So he inherits from person. But he can also fight. So we'll say he has a method called fight. And when he does that, he causes 10 health points of damage. So we'll say print, do 10 health points of damage. There. So let's run our fighter instead. Now let's run him with heal and see what happens. That's going to throw an error. So the person doesn't have heal, and fighter is inheriting from person. So he doesn't have the heal method. That's only the doctor. So let's do something that he can do. Let's fight. Now he does 10 health points of damage. But let's do something else. Let's override the original move function, because it turns out that our fighter is actually quite nimble and quick. So he can move faster than a normal person. So he also has a move method, his own or her own. Self. Copy this. And instead of moving 4 paces, our fighter can move 6 paces. So this time, let's see what happens when the fighter moves. Now he moves 6 paces. So that shows you a little bit of what we can do with simple inheritance. But we can also inherit from multiple classes. We'll add another character in our game, the class wizard. So a wizard can do all the things that a doctor can do. So we'll inherit from the doctor. But he also has his own special method, which we'll call cast spell, which turns him invisible. And we'll also override the original Dr. Heal method so that our wizard doesn't heal 10 points, he heals 15. So let's see what happens there. So now we'll create a wizard instead, and we'll heal. Now he heals 15 points. So now we've inherited from the doctor, which in its turn inherited from the person, which means that the wizard can still move because that's inherited from the person. What we can also do, the wizard is sort of a mix between a fighter and a doctor, right? So we could inherit also from the fighter. And that means, of course, that we get these methods as well. So what happens if we move our wizard now? Now he moves 6 paces because that's closer in inheritance. So that's the moves that he's using from the fighter. And that's the way in general that the inheritance works. And also if you have 2 that collide, it will choose the one that's first in the list if you have 2 methods on both. So that's an introduction to inheritance and multiple inheritance. And there's lots more to learn about inheritance. But let's leave it here for now. I'll talk to you next time. Modules. Now we're going to talk about something in Python that's going to make you look like a much better programmer than you actually are. So when you write code and functions, After you get a lot of it, it makes sense to package the code according to use, putting related code in the same files or modules. And then when you need to use some of that code, instead of just copy pasting it, in Python you can import that file or module and access the functions, objects, or whatever is inside. Now there are lots of modules you can use in this way, from those that are packaged with Python to those created by other programmers, just like you and me. And they might be made to solve specific problems. And you can use them as long as you can find them, you can import them. Now modules are a really big and important part of Python, and they're imported all the time. So learning how to use them is an important part of your journey to awesomeness. Some common ones are datetime for date objects, random for creating random numbers or strings, string for working with string, OS for various parts of the operating system, math for more advanced math functions, browser when you're interacting with the browser, and so on. There are lots and lots of these. In this course so far, we haven't actually imported any modules, but we've just run basic Python commands. To import modules, we need to add some stuff to our workspace over here in the index file. So let's look at this. So the reason we can run Python at all is this Brython add-in. And as long as we're running with this Brython min.js, we can use normal Python commands. Now we need to use this part as well, the Brython standard library, which is bigger, which is going to make the whole interface a bit slower, but that means we can start importing things. So now we've changed that. And a good place to start when you're looking for modules is this URL. So you can copy that into your browser and go check some different modules. All right, so modules. They're really simple to import. All you have to do is write import, and in this case, we'll import platform. And when you import a module, a good thing to always do is to check what it does. And a command to do that is the dir command. And then you run that on the module. So let's run that. That gives you all the methods inside the module. In this case, we're going to try out the Python version. So let's do that. The way you call it is by saying platform Python version. Now if we run that, it's going to show us the Python version we're running, 3.7.0. So if we wanted to import more than one module, we could do that by separating them with a comma. So we could import platform, string, and OS. And if we want to access any of those functions inside those modules, we would prefix them with the name, so string or OS or platform. To shorten our typing a bit, we can import them and give them an alias. So we can say import platform as PL. Then I would just change the platform to PL and run it. Now when you do this, you can no longer use the platform command. So if I write platform, it's going to throw an error. So you need to keep track of what you're doing with that. Now to make life even simpler, you might want to import just this Python version, so you don't have to type it all the time. From platform, import Python version. Now we're explicitly just importing the Python version. And if we want more functions, we can import system, for instance, which is also one of the functions. So now we've imported just those two. And now when we want to access them, we don't need the prefix. So we can just run Python version directly. So now if we run that, we get the same result. And if we wanted to run system, that works too. It shows us the system we're on. So let's go back to our Python version. And this we can also alias. So we can say from platform import Python version as PV. And then we can call this function simply by calling PV. And this will no longer run because we haven't imported that. So we'll comment that out. Run it again. Whoops. And I forgot the as. So from platform import Python version as PV. There we go. So those are some ways to import modules and aliasing them and importing multiple versions of them. I really suggest that you go check out that URL and see which ones are there and try this out on your own. And I will speak to you next time. Oftentimes when you're programming, you want to combine different iterables. And iterables are strings, tuples, lists, and so on. Things that you can iterate through. So in this case, we have 3 different lists, and we're going to combine them in some different ways to see how to use the zip command, which is really convenient. So let's start by creating a new variable, which we'll call combo. And the combo will get to zip nums and letters. And then we'll print whatever is inside combo. Let's run that. We get a zip object, and we can't really see what's inside it. So let's turn it into a list. Run it again. Now we see that we get a list of tuples, and they are matched by index number, and that's what zip does. If you have 2 iterables of the same length, it's going to match them. The first object in the first iterable is going to match with the first object in the second iterable, and so on. Now interestingly, now we've had 3 lists, but we could actually change this to a string without the commas. It's still going to be iterable. So the first one, the 1 is going to be the first 0th element, and then 2 is going to be the first, and so on. So if we run that, is it still going to work? You bet. Except now they are both lists of tuples with strings in them. So I could have turned this into a tuple equally, but it turns out I can actually turn it into a dictionary as well. And if we run that, we directly get a dictionary, not a bunch of tuples inside a list, but we get a real dictionary. And that's quite convenient and something we can use from time to time. We can also add even more of these iterables. So let's add the names. Now, of course, the dictionary isn't going to be of much use since it only takes 2 values. So let's make it a list again. Run that. As you see, now we have a list of tuples with strings in it. Then, sometimes we might want to take this apart. In order to take them apart, we can still use the zip command, but we can unzip instead. But it's not called unzip. You can do it this way. So we'll define 3 variables, num, let, and nam. So that's for numbers, letters, and names. And then we're going to run the zip command, but basically unzipping. And to unzip, you use an asterisk. And then we unzip the compo. And what we're doing now is actually immediately assigning the results of this unzip into 3 different variables, and that's something called unpacking, which you can also do in Python, which again is also very convenient. So you see the results, we have the list of tuples, and then let's print the results. So we'll print num, let, and nam. What we did in the first step with the unzip is something called unpacking, where we immediately assign the values of that unzip to 3 different variables. And now we're going to print the results. So there we go. We're now back to what we started with, except they are tuples now. If we want to turn them into lists, we can do that. So that's zipping and unzipping. Now let's look at a special case with dictionaries. So here are 2 strings, the keys and the values. And the top one is English, this parrot is deceased. And the second one gives you a chance to learn some Swedish. That's denna papegojan är avliden, which means the same thing, just in Swedish. So let's turn this into a translation table. Now the keys and values aren't that easy to iterate over since they have the spaces inside them and it's not obvious where they're actually separated. So the first thing we can do is split them into lists. So we'll say keys, split, and we'll split on white space. And we do the same thing with values. So they get values, split. If we now print these, keys, values, we get the following. Now we have 2 lists. So that's awesome. So let's try and zip those into a dictionary. We'll call it English, Swedish, dictionary. And the way we'll create it is by calling a dict on keys and values. And then we'll print the English-Swedish dictionary. Now we have a dictionary that says this is denna, parrot is papegojan, and so on. There's a second way to create the same dictionary, and that's called dictionary comprehension, very similar to list comprehension. So let's create a new one, a new dictionary. The way we'll create it is we'll say, this is a dictionary, we want the key and the value for key, value, in zip, keys, values, which we have created above. And if we print this, it should be the same thing. And lo and behold, it is the same thing. So that's 2 different ways of doing the same thing. What about if we want to take this dictionary apart? That's not exactly the same procedure as we would do for the zip lists we created before. So one way would be to use the dictionary's keys and values methods. So we could do the English and Swedish, get, and we now need 2 different values here. So we have the en, sv, dict. We'll start with the keys. And then the second value is a list of English, Swedish, dict, values. Won't parentheses too many. And then we'll print the ENSV. Run that. Whoops. That's where the extra parentheses came from. So let's try it again. There we go. Now we've broken it apart again. We have a list. This parrot is deceased. And we have the Swedish version. Another way we could do the same thing is to say en1, sv1, get, and this time we'll unzip it instead. So we'll say zip asterisk en sv dict items. As you may remember, the items contain all of the items. And then we print those, run that, and we see that we get the same result, but it's now tuples instead. So if we wanted lists, we would need to cast those into lists. All right, so that's some zipping, unzipping, and a little bit of playing with the dictionary. So I'll see you next time. Lambdas, or anonymous functions, exist in Python and allow you to write single-line function definitions that you might just use once and then throw away. Or you can use them multiple times and give them a name. They can be quite convenient, but aren't always the right thing to use. So let's look at some examples. Here's the function for a square, which returns x multiplied by x, so squaring the number. And then we're printing the result, so the square of 3. So if we run that, we get the result 9. If we were to rewrite this as a lambda function, lambdas are defined in the following way. If we want to give it a name, we can. So name gets, and then we say lambda, which is the keyword. Then we specify the parameter we want to use, or the parameters, a colon, and then the actual expression. So as you see, it's quite similar, but not completely like creating a function. So let's try and write the above function as a lambda function. So we'll say square, let's call it 1, gets lambda x colon, then we have the expression x times x. Now the return value is implicit in a lambda function, always. So it always returns a value. A function doesn't have to return a value. All right, so let's run square number 1. And we see we get the same result. Put the print up here. So that's fun, but how useful is it really in this case? We could write a single line function definition instead, saying def square 2, and then specify the in parameter, a colon, and then return x times x. And that's also valid syntax for creating a function. So if we run that, we also get 9. So as long as it's just on the one line, you could use either of these. But let's focus on the lambdas. So we'll delete this, and let's say we have a double multiplication function. So we have two in parameters, x and y, and we multiply 2 times x times y. Now if we want to call this, they change that. So let's send 2 and 3. That gives us 12. So 2 times 3. So that's how you write a lambda function, but so far we haven't really made them very anonymous. But let's try a different scenario. Let's say that we're taking a username and an alias from an input box in our program, whatever the program is. And then we want to clean those up and put them together, separating them with a colon. Okay, let's write a function for that first. Parameters name and alias, colon. And to return, we want to take the name and strip out any leading spaces or trailing spaces, and then also titleize it so that we have a capitalized letter starting. So the way we do that is we take the name, we start by stripping it, which is a method on the string, and then we also make the first letter a capital letter. Then we concatenate that with a colon, and then with the alias, where we do the same thing. So that's our function. And then if we print an example, so let's say we have, and the string we take in is, let's say somebody doesn't know how to type, John. That's messy enough. And then as a second string, we take in his nickname or alias, Heckler. So if we run this, let's get rid of that top stuff. We've now tightened it up so it says John Cleese, Heckler, nicely capitalized. But we can actually write this as a lambda as well. So let's say name and alias 1 gets, and we'll copy this. We'll say lambda, and we'll take in a name and an alias, colon, and we'll paste the part we just copied. Now if we run name and alias 1, we should get the same result. We'll copy that. We get the same result twice. And naturally, we could do exactly the same thing by doing a one-line function definition, which to make it easy, we could just copy this, place it here, and since it's on a one line, we just bring it together, and we call that name and alias 2. Change this to 2. And we also get the same result. So these three methods do exactly the same thing. So let's do something different. Let's say that we have this list of Monty Python members. And then let's print our list. So there's our list. Now let's say we'd like to sort this list. We could do this using a lambda function. So we could say sort using the method, and then as the key, we will input a lambda function. So let's say lambda. We'll use the parameter name, and that name we will split on space. So each one of the names will be split on space. And if we run this, they should be ordered by their first names. So now Eric is before Graham, is before John, is before Michael, Terence, and Terry. So if we wanted to order them by their last names, we would simply say -1, accessing the last part of that split string. So now they're in order of last names. We could do exactly the same thing by creating a function. And that function could be So that would be the equivalent function. And if we run the same sorting function using the key, but now just importing the name of the function, we will also sort. So now it should first sort by last name and then print out a second one, and then sort by first name. So let's input another print statement. There we go. We'll run that. So the first one is sorted by last name. The second one is sorted by first name. So that was an introduction to lambdas. In the next tutorial, we'll dig deeper and see how you can use lambdas to get functions inside of functions. I'll see you then. Welcome to part 2 of lambdas. So last time we ended up with this sorting function, and we saw that we could replicate most of the lambda functions with regular function calls. In fact, you can always replicate a lambda with a function call. But there are some instances when lambdas really come into their own, and we'll take a look at when that is. So let's start with defining a function of n and have it return just n. If we print this and pass it the value 3, we get 3. If we take a look at the type of the return value, we should find that it's an integer. And it is. However, what if we do a lambda here? So we say lambda, a, the parameter of the lambda function, and then we have a times n. What will be the result now? Now we see that the return value is actually a function. Now, so far in this course, we haven't had return values as functions before. What it means is that we're actually receiving a function, and functions can take in parameters, right? So what this actually means is that the function we have is outputting a new function that's using the n value in that function. So the new function that it's outputting in this case, a times 2. So if we created a new function to use this, let's call it doubler, it would call the function with 2. Now this looks like we're just assigning a value to a variable, and we are, but we're assigning a function to the variable. So if we were to run this, say print doubler, we would get a function lambda. But if we send an in parameter, as the lambda value wants, because it's saying lambda a, if we send the in parameter 3 as an argument, we get 6, because essentially our value, 3, is being multiplied by 2, which we specified when we created the function. So if we create another function, which we call the quintupler, or quintupler if you prefer, and we say that that is the function of 5, and then we print that of 3 again, that should give us 3 times 15, and it does. Now this may be a bit abstract, so let's use a specific example and see how that works. Leave this for now. We'll create a new function. And this function is for, let's say, our consultancy, where we calculate the price based on a startup cost and then an hourly cost. So let's call it price calc. And it takes in 2 values, a start value, or a startup cost, and an hourly rate. So what we're going to do is use this function to create new functions that we can use depending on what type of clients we have. Because essentially, let's say we have 2 clients. We have people that just walk in from the street, which we charge one rate. And then we have clients who are premium clients, who are charged a different rate. So let's return a lambda that takes in the hours. And then it takes the start value plus the hourly rate times the number of hours. So that's our new function. Now we'll create 2 functions. We'll call the first one walk-in cost, and we'll set that equal to price calc, $10 setup fee, and then we'll charge $30 an hour. So that's our first function. And then we'll print walk-in cost of a 2-hour treatment. Before we do that, we'll get rid of these. Let's run that. We get $70. Now let's say that we have a premium customer, our best customers. So premium cost, we set that equal to price calc. And let's say that we only have a $1 setup fee and we only charge $25 an hour. If we print that as well, copy that, call that premium for 2 hours, we get a different result, $51, $1 setup fee, and then $2 at $25 an hour. So now we've created functions that we can reuse in this way by using lambdas. Another thing that lambdas allow you to do is call the function immediately. So you can call it as soon as you create it. So for instance, if we say, and we have A, B, and C, colon, and we have A plus B plus C. And then we can call this function immediately with 3 numbers, 2, 3, and 4 using positional argument notation. So the 2 goes into the A, the 3 into the B, and the 4 into the C. And then we need parentheses around this whole thing. So that equates to 9. Now that means that we could call the price calc function directly using the same kind of values. So we could say price calc 125, which is our premium calculation. We want to print it. And then the function that we get, we want to call with the value 2 for 2 hours. So that will give us the same result. We have 51 twice. So that's one way you can call lambdas. Another way, you copy this, is to use default values. If you're going to use default values, always remember to put them last. So let's say that we use ABC, and we'll cut away the last parameter. So that way the default value, c equals 2, is going to be used. So what do we get? We get 7. We can override it by putting back the number again, and we get back to 9. But again, remember to put your default values last and the values that you have to use before that. So don't mix them. Another way you can call them is to name your arguments. So you can specify that this is B and this is C. And as you remember, it doesn't matter which order you put them in if you start naming them. So if you run this, it gives you the same result because, of course, we've thrown them around, so it doesn't really matter which one we put where. The last kind of neat thing to use is to use unpacking when you're working with arguments. I'll show an example of that. If we start with this, and then instead of saying ABC, let's say args, and you can call that anything you want. And then you put an asterisk in front, which will then unpack any arguments you send it. And instead of saying a plus b plus c, let's just say sum of the arguments. So if we run 2, 3, and 4, that again gives us 9. But let's add another argument. Let's add 50. Now you've created something where you can keep adding arguments. So that covers an introduction to lambdas, and we'll continue to introduce some new concepts in the exercise. All right, welcome to this exercise with lambdas. So the plan is that we're going to look at some different functions, and then it's going to be your job to turn them into something lambda-ish. And I'll walk you through it, and then you get a chance to try it on your own, and then I'll show one possible solution. You ready? Let's go. So here's a function on one line, and if we run it, we see that it inputs the number 7, because the function is using the input x, it returns x plus 5. And then we're inputting 2 as the x, so it's x, which is 2, plus 5 is 7. So your job is to turn this into a lambda function. And I've gotten you started here with f equals, and then you just type in whatever you feel should be the lambda function. Okay, so one way to do this is simply to say lambda x colon x plus 5. And we'll comment out the old one and run this one and see how that works. And we get 7 again. So that's rewriting a single line function to a lambda. Here's our next one. We have a function called strip spaces, which strips the spaces from a string. And if we run it, we see that all the spaces are removed. So your job is to write a lambda version of that function. So give that a try and I'll be right back. As we've said previously, lambdas are really only a different way to specify a function. So we can take this old function and we can say lambda, then we'll use the str as the variable, and then we'll paste in the same string that we had up here, the code. And then if we run strip spaces 1 instead, that should work. And it does. So we got rid of the spaces. So here we have a function which joins two lists and removes all the duplicates. And the input is list A and list B. We've got list A and list B, and our job is to write a new function that does the same thing using a lambda. So let's first see that it works. Yes, it outputs a list without the duplicates. So now, here's your new function. We'll call that 1 as well, and then I'll come back and show you a solution. All right, so one way to do this is to say lambda, and then we'll bring in list A, and then list B, colon, and then again, we're reusing the same code. So why don't we just copy this code? There we go. And then we run list no duplicates 1 instead. And we get the same result again. Awesome. All right, so here, complete the function so it returns a function. So this is a function inside a function. So here's the function we have. we've got create quad function, inputs a, b, and c, a docstring, return function f of x equals ax squared plus bx plus c, and then we return a lambda function. So your job is to write this lambda function that should be here. And then you create a function called f, which we've written all the code for, and then you write your own code for a different function g, and then at the end, print the results of both of them. Give that a shot, and I'll be back to help shortly. All right, so here we really only need to follow the instructions above. So we've got a times x, and then raised to the power, which is 2 asterisks, 2 plus b times x plus c. And then we create our quad function, 2, 4, 6, and then we create another one. Basically, we just have to copy this. The syntax is exactly the same. And let's input some other numbers. Let's say 1, 2, and 3. We run that. We get 22 and 11. Awesome. So here's a sorting exercise. Imagine that you run a fan club, in this case the Monty Python fan club. And you have a bunch of members, and you've asked them to sign up for an event. These are the members that have signed up, and you'd like to sort them. So if you sort them using a normal sorting, you will get the following result. Okay, so that gives us a sorting, but not quite the sorting that we'd like. This is what's called a lexicographic sorting. So it's sorting first 3 letters, and then it's seeing the number 1. It's not seeing it as 104, but it's seeing it as the number 1. So that comes before any number 2. That's not what we want. We would like to sort this according to integers instead, as we are used to seeing. So the question is, how can we bypass the letters and go directly to a sorting that makes sense to us? So try and write this function using a lambda inside here. I'll see you in a bit. Okay, so what we're sorting is the signups, and the key that we'd like to use is a lambda. Why don't we call it ID, and then we'd like to sort ID, and then we want to slice that string and use everything after the third character. So we don't want the M, P, and F. We only want whatever number comes after that. So that's 3, which is the 4th position, and then all the way to the end. So we don't specify anything. And then we'd like it to sort on integers instead. And then we close off the parentheses, 1, 2, 3. And with a bit of luck, that's going to work. So there we go. The first one is sorted lexicographically. The second one is sorted maybe the way we'd like it to be. Continuing on. So we have a class here called a player. The player has a name and a score. So maybe it's somebody who plays a computer game. We then create 3 players, Eric, John, and Terry, and we put them in a player list, Eric, John, and Terry in this order. And we specify their names and their scores. Now, our job is to sort this using score so that we output the players in our list according to their score. So here's the print function that we're going to use, and here's where you write the code. And basically what you're going to do is just sort the player list based on the score of the different players in that list. Okay, give that a shot, and I'll be back. Right, so one way to do this is to say player list. We use the sort method on the list using a key, lambda, and then we can call it something. What we call it doesn't matter, so let's call it player, player, and then what's the attribute? This one, score, right? So player.score, and then we're going to print it. So let's see how that prints. Okay, so now we have John, Eric, and Terry. So John has the lowest score, Terry has the highest, and he's the last, so that seems right. Then if we'd like to, we can turn this around and say reverse equals true. Then they get sorted with the top scorer first, and then the middle one again, and then the one with the least points. So that's that exercise done. I'll see you in the next tutorial. Okay, let's talk about comprehensions. Python comprehensions are a really cool tool that allows to create lists, tuples, sets, and even dictionaries with a lot less code. They're sort of an evolution of maps and filters together with lambdas, but they require less code and are easier to understand. So anything you can do with a comprehension, you can also do with a for loop. So you can use a for loop, it just requires more coding, or more lines of code at least. And since you're at least as awesome as comprehensions are, I'm sure you're going to get along great with comprehensions. So let's get cracking and start trying to comprehend this. So as our first exercise, what we're going to do is try and take the list of numbers, and we are going to square each one of those numbers and print out that list. So the first thing we need to do is create a list. New list, gets, and an empty list. Then we'll say for num in numbers, we're going to append to this new list. So we indent and we say new list append, and we're going to calculate num times num. And we're done, and we're going to print it. So print new list. Here we go. Let's run that and see what happens. So we get 1, 4, 9, 16, 25, 36, 49, 64, and 81. Okay, great. So in order to write a comprehension, one thing we could start with thinking is think of this instruction that we had as a sentence. So look at this sentence. Give me a list with num squared for each num in numbers. So that's sort of a sentence way of saying what we wanted. So let's think in that way while we write the comprehension. So we want a new list. And that's going to get some form of list, right? Okay, so we have the list. Then inside the list, we want num squared, okay? So we'll write num times num for num in numbers. And then again, we print new list. So let's see what happens with that. We get exactly the same result. So we managed to do the same thing that the for loop did, but with a bit less code. So now let's modify this a bit. Now let's say we want a different thing. Let's say that we want this instead. Give me a list with num for each num in numbers if num is even. All right, so let's create that list instead. Let's say we want num for each num, so we got that, in numbers, and then there's an if statement that we need to add. And the if statement is if the number is even. And how do we figure out if a number is even? Well, we take the modular 2 of that number. So if we divide the number by 2 and it has 0 as the remainder, then it's an even number. If it has 1 as the remainder, then it's an odd number. So let's say if num modulo 2 is equal to 0. All right, let's see what we get. Now in the second printout, you see we get 2, 4, 6, and 8. So now we're no longer squaring the numbers, we just get the number printout. Now if we wanted to get the odd numbers, we could set this equal to 1 and run it. Now we get 1, 3, 5, 7, 9. Another thing we could do is to say not equal to 0. That would also get us the odd numbers. But let's get back to the old one. Now we could do exactly the same thing using a filter and a lambda function. And that would look in the following way. So we could say new list, filter, and then a lambda function. And the lambda function would be num colon, because we just want the num, then num modulo 2 equals 0 and applied on numbers. Then we print a new list again, but the filter is actually going to give us a filter object. So we need to turn that into a list in order for it to be printed properly. So let's try that and see what we get. There, we get the same result. Now filters are just more complicated to use in my view. All right, so let's look at another example. Let's say that we want a letter number pair for each letter in spam and each number in 0, 1, 2, 3. How would we do that? Well, with the for loop, we can simply do this. So we create a new list, for letter in spam, so that's going to iterate through the string, spam. Then for num in range, 4, so that's 0, 1, 2, 3. To the new list, append the letter and number, and then print new list. So let's try and run that, and we'll comment out these other ones for now. So let's run that. Now you see we get tuples inside the list that contain the letter and then a number, and then the same letter and the next number, and so on, and it loops through that. Now you could create this using a list comprehension instead by reading that text above. We can say new list gets, it's a list, and the first thing we want inside is a tuple of letter and num. We want that for letter, so if we read the text, I want a letter num pair for each letter in spam and each number in 0, 1, 2, 3. Okay, so for letter in spam, for num in range 4. And again, we print the new list. And if we run this, we'll see that we get exactly the same thing. Now, I've created a slide down here, which I'm going to show you. So the comprehensions actually contain exactly the same code as the for loop. So if we take the for loop here on top, we'll see that we have the new list in blue, for num in numbers in red, and then in green we have new list append. If we look at the list comprehension, which is on the next line, we'll see that we have the blue, we have the green, and we have the red. And then we have the blue at the end because that's of course the square brackets for the list. Now the same thing goes for the last one we just did. We have the new list on top, for letter in spam, for num in range 4, new list append letter number, and then we have the comprehension at the bottom with the same color coding. So you can look at that if you feel a bit confused about how to create these, just to see that all the code is actually there, it's just structured in a different way. All right, so that was an introduction to comprehensions with lists, sets, and tuples. And in the next tutorial, we're going to go through dictionary comprehensions, and that will follow on directly from this one. I'll see you in the next tutorial. Okay, so let's clear up our code here and look at dictionary comprehensions. So here are a couple of Monty Python's movies, and then the year that they were produced, and then the names of the people whose favorite movie that was. Now that's actually not a real list, I just made that up, so bear with me. So let's say that we'd like to create a list that contains the movies and the year. So let's try that. So we could do that by saying print list. Then we need to zip the two lists. So zip movies and year. If we run that, we get them combined as tuples inside the list. Okay, great. So using the same analogy that we had with the sentence, let's try the same thing for this dictionary comprehension. So give me a dict, movies year, for each movie's year in zip movies year. All right. So if we were going to do that with a for loop, we could say new dict gets, and then an empty dictionary. Then we would say for movie year in zip movies year. And with a colon, and then we have what we're going to do. So new dict movie year. And then we're going to print our new dict. Let's see what that gives us. Now we get it as a dictionary instead, the same information, just differently structured. Now how would we write a comprehension to do exactly the same thing? Well, let's give it a shot. Let's look at that sentence up there. Give me a dict, movies year, for each movies year in zip movies year. We'll start with a dictionary, new dict, and that gets a dictionary, right? And then inside that dictionary, we say movie year for movie year in a zip of movies year. And we print the new dict. Is that going to work? Yes, it does. We get exactly the same result. So the comprehension did the same thing as the for loop. So now let's say that we want to add some stuff to this. Let's say we only want the movies before 1983. How would we do that? Well, let's extend our comprehension. Let's add an if clause. So let's say if year less than 1983. What do we get then? Let's take a look. We now get a shorter list of only the movies that were before 1983. We don't have the Monty Python Live or Monty Python's Meaning of Life. So that's awesome. Now, what if we only wanted movies before 1983 that start with Python? So let's add another condition. So let's say, and movie, and then since the movie is a string, we can use the method on the string, which is called starts with, and the string is going to be Monty. So let's see what we get now. Now we only get the ones that start with Monty, which are only 3. The Holy Grail, Life of Brian, and Live at the Hollywood Bowl. Great. Now let's say we want a list that prints out movies that each person liked. We'll create a new variable. I'll call it N1. But let's say that we create a new list that contains a tuple of name, movie, and year. For name, movie, year in the zip of all 3 lists. So we have names, movies, and year. If the year is before, let's say 1981. And then let's print N1 and see what we get. So at the bottom there, we now see John, and now for something completely different, 1971. Eric, Monty Python and the Holy Grail, 1975. Michael, Monty Python's Life of Brian, 1979. Okay, let's say we want to add some actual text to this, so make it more of an information string. So let's go in here and change it slightly. So we'll say, encapsulate this in a list, and we'll say name, then concatenate that with some text. Favorite movie was, plus the name of the movie, which was from, and then the year, and because the year is an integer, we can't put that in the string, so we have to make a string out of it. So we have to typecast it into a string, like that. And then if we run that, we get a text. John's favorite movie was, and now for something completely different, from 1971. We should probably add a space there. Now, Perfect. All right. I hope that was a good introduction to comprehensions and that you got something out of it, and I'll see you in the next cast. The world around us is often seen to be random, and when you're programming, sometimes you want to mimic that randomness. In Python, you import a module called random when you want to work with randomness. The randomness you create with that module is not true randomness, it's almost true randomness, something people generally refer to as pseudo randomness. When you want to do really secure random generation, you should use some different modules that are also part of Python, but for some reason I can't get to work properly in this interface. But let's get started with the pseudo randomness. So some things you might want to do is control characters in games or different things that happen in games, or maybe even generate random lists of characters and words. So the first thing you want to do is import the random module. So we'll do that. Import random, and it still runs. That gives us access to the various random functions. Now that we've imported the random, we can run functions by calling them. So there's a function called random, which generates a number between 0 and 1, but not 1. If we wanted to instead generate 5 numbers, we could use a for loop. So we could say for I in range 5. We get 5 different random numbers. So that's a number between 0 and 1. But what if we wanted to generate a number up to, say, 6? Well, we could multiply this number by 6 to generate that. So now we get a number up to 6. A different way to specify this ourselves would be to use a different function. So there's a function called uniform. And uniform takes 2 arguments. The first is the first number it should start at, and the second is the second. So now we're generating a number between 1 and 6. Let's try that. Now we have 5 numbers between 1 and 6, but these are all floats, and we might want to have integers instead. Naturally, there's a function for that as well. So let's start with the simple one, where we're actually mimicking a dice roll. So we can use the randint function, which is similar to the uniform function, in that it's going to generate a number between 1 and 6, 2, 3, 5, 5, 5. You could also change this to be a range. So call randrange, and then it takes a third argument, which is the step. So if I do this, say from 1 to 100, it's now going to choose numbers between 1 and 100 with a step of 2. So it's going to choose from the numbers 1, 3, 5, 7, and so on, up till it reaches but not goes over 100. So that means just odd numbers. Let's run that. 9, 89, 91, 55, 87. So that seems to work. If we set it to 2, it would instead choose even numbers. But we don't just have to work with numbers when we're doing randomness. Get rid of this for a moment. Let's add a friends list. And that gets our old friends John, Eric, Michael, Terry, and Graham. If we have a list, we can choose from that list using the random functions. So in this case, we'll say print, and we'll make a random choice from the friends list. And the way you do that is you say random choice friends list. That gave us Graham. If we run it again, it will give us Graham again and Graham again. That is weird. Now we got Terry, fooled by randomness. If we want to draw multiple names, we can use a different function called sample. So we replace choice with sample, and then we say how many samples we want. Now sample is a bit special because it only draws a value once, so it's not going to draw any duplicates. There's another function that does that called choices, but for some reason I can't get it to work in this platform. Probably just a lack of skill on my part. So if you use this, you're not going to get any duplicates. So it would be impossible for me to draw 6 because that's bigger than the list. So I can only draw the whole list. Another thing we can do is to shuffle. So let's shuffle the list. You can say random, shuffle, we'll shuffle the friends list. And then after we've shuffled it, let's print it. There we go, that's the first shuffle. Let's shuffle it again, and it changes order. So that's working with lists and numbers, but we can do some more things. Move this, and paste in this. So here I have the small caps letters, large caps letters, and the digits, which you might want to use when you're generating random strings. Now luckily people do this so much that there's actually constants that hold these values. And in order to get those constants, we're going to import another module called string, and we'll comment that out, run it once. And in order to access these constants, we can create a new one called letters and numbers. And we'll set that equal to string ASCII letters. and we'll concatenate that with string digits. So the first one holds both the small cap and large cap letters, and the second one holds the digits. If I wanted to access just the lowercase, I would say lowercase or uppercase. In this case, we want all of them, so we'll say letters. And let's take a look at that. So we'll print letters and numbers. So there's the whole string that we've imported. All the small caps, all the large caps, and the digits. So let's do something with this. Let's start with a variable. We'll call it word that gets an empty string. Then we'll do a for loop for I in range. Let's say we want 7 characters. We'll say that the variable word is equal to word plus random choice letters, numbers. And what this should do is generate a string of 7 characters. And then instead of printing the letters and numbers, we print word. So here's our string. Now the first thing we could do is use different notation. Say plus equals instead of this word plus, make it a bit shorter. That's going to do the same thing. If we didn't want to repeat any of the characters, we wouldn't need the for loop. We could use, say, word1 gets join random sample letters, numbers, and then 7. We'll print that. That also generates a string, but it will never have any duplicates. Now, without even having to use the join function, we could use that function I mentioned before, the random choices. So it would be very similar to the one above. So word gets random choices, letter, numbers. And then you can say k equals 7. So that's the number you want. But again, as I mentioned, that doesn't work in this platform. It does work in any other Python implementation you'll run, and it will save you the for loop. And this will generate one where the strings can be duplicated. So that's a little bit about randomness. And as I mentioned, this module isn't truly random, it's pseudo-random. So if you want to use something for cryptography or for generating passwords, you should probably use one of the strings inside the OS or the secrets modules. Good luck with your random generation, and I'll talk to you next time. Let's talk a bit about performance and how to measure it using the TimeIt module. So earlier today, I looked at some code for the sieve of Eratosthenes, which is basically a way to find the prime numbers within a certain range. So this was the code. It's a list comprehension that runs through all the numbers from 1 up to 150 and checks that as long as the modula of none of them is equal to 0 for all the numbers from 2 up to x, and x is the number here. So this number is going to keep increasing the whole time, and also checks that x is not equal to 1, and that x equals to 1 only happens that first time. So I suggested maybe you could remove the back end of this, making it like this, removing this and not x equals to 1, because that really only happens the first time with the first number. And we know that 1 is not prime, so why don't we just start at the number 2 instead? Okay, so let's see if these both run. And they give us the same result. That's good. But how do we know which one is faster? Well, at this stage, we don't know. We just know that they both give us the same result. I mean, I made the claim that the second one should probably be better, but do we really know? I mean, is it a lot faster or just a little bit? So let's look at another way to solve the same problem. This code right here, which starts with an empty list, and then it runs through all the numbers in the range 2 to 151, again skipping 1, and then it assumes that the number is prime until it's shown to not be. So it starts with setting is prime to true, then it runs through the range 2 up to the integer of the possible prime raised to a half, which is the square root, plus 1. So that's the number after, so that we actually include the number we want. If possible prime modulo num equals to 0, then we set is prime to false, and we break out of this for loop. If it is prime, then we append it to this primes list that we have up here that started out as empty, and then we append numbers to it as we go along. So let's make sure that works as well. And it does. So how do we figure out which of these is the faster code? The two first ones look shorter, right? They're list comprehensions. They look really nice. And the second one is all messy and a bunch of indents. And I wonder if that one's any good. It doesn't really look like it, does it? So how do we do this? Well, we can use the TimeIt module. And because we're going to import something really important when you're in Scrimba, you need to make sure that this bit here, the Python standard library.js has now been uncommented, which it's normally commented in most of the code that we run, unless we're importing something. So keep track of that, otherwise you're not going to be able to import, and it's not going to fail, and you're not going to know why. So let's import the TimeIt module. Well, that was easy. And then what we're going to do to use that, there's a function inside TimeIt called TimeIt, and we're going to use that. And in order to do that, we're going to encapsulate these calls inside functions. So let's define a function called test1, test2, and test3, and let's put the code inside it. So we'll do that, colon, and we'll remove the print, because we don't want to print all this stuff. There we go, so that's our first one, and we want to return something. And when using the TimeIt module, it's really important to have a return value, otherwise the TimeIt module is not going to work. So we return 1, great. Let's do the second one, def test2, like so. We indent that again, remove the print, remove the end parentheses. This one's going to get trickier, def test3. So now what I want to do is indent all of this code, and for some reason that almost never works for me. There we go, indent. It didn't work this time either, did it? Maybe it did. And we don't want to print, and we want to return value. So why should we return anything other than the same we do in the other ones? So return 1. And now we're going to import the actual TimeIt code, which I pre-recorded. There we go. Fantastic. That's how fast I can type. So we're going to print the timestamps telling us how long this took, and we're going to run 10 cycles of each of these. So the first line here, print TimeIt is that function. We're going to call function test1. There are no arguments to send. And we have this part of the call, globals gets globals. And then we have the number of iterations we want to run. So in this case, 10. So you see I have test1, test2, test3. Let's make sure that's correct so that I haven't typed them in a different way. Test1, test2, test3. So with a bit of luck, this should run, and this should tell us which of these is faster. So let's try it out. And as I said, it actually did fail on my indentation. So let's run through the indentation and make sure we do this right. So the 4 is there, there's the error. That goes in, this goes in, and these go in. Now it should be okay. Let's run it again. And there we have our results. So we see that the first ones took about 3.8 seconds to run 10 iterations each, and the last one took only 0.17 seconds to run 10. Wow. So if you thought that running list comprehensions was a lot faster, that's not always the case. Code that looks messy can very well be a lot faster than other code. And the reason the list comprehensions are kind of slow are mainly to be found, I think, in this area, because you're always running through these long loops that increase in size the higher you go. So that's an interesting performance result, and I hope that taught you how to use the TimeIt module for easy timing of your code to see which runs faster and slower. Now just remember to run a number of iterations, but not too many, so that you can see a difference. All right, I'll see you next time. Hey, welcome. I thought we'd do a project together, and the project is making a crypto machine. So the idea is to build something where we can enter a message, we can decide to either encrypt or decrypt the message, and then we get a plain text message. We take that message, we send it back into the same machine to get the decrypted message back. That way, we can send messages to each other and nobody can read them except us. That's cool, right? And we'll call this something exciting, maybe Enigma. So I'll start by listing the different things we probably need to do in this project. And then I suggest that as we run through, when we've completed one part, try the next one on your own. And then when you've tried it, come back and take a look at what I've done. Then you can, of course, laugh at my complete ineptitude at coding. All right, how does that sound? Great, let's get started. So first, we want to create our keys. Create key string. After we've done that, we want to auto-generate the values string by just changing the original string because we're lazy and don't want to type it twice. So, as the next step, we want to create two separate dictionaries, one for encoding and one for decoding. As our next step, user input, message, and the mode of the crypto machine, encrypt or decrypt. Next step, we either run encode or decode. Then we want to return the result. And at the very end, we want to clean up and beautify the code. So those are basically the steps. So let's get started. So number one, which we haven't even typed here, let's start by creating a function. So we'll say def enigma, and we'll call it light. There we go. go down here, indent, and then we start keys. So this is a string variable that we're going to start with. Could be something else than a string, but let's start with a string because it's easy. So how would you do that? Well, I'm going to do this. And I'm going to add a space and an exclamation point. There we go. In the dictionary, that's going to be our keys. Okay, then we want to auto-generate the values string by offsetting the original string. So we're going to generate the values. How would you do that? I'm going to do it this way. I'm going to say keys, then I'm going to slice the string. I'm going to start with the last letter, then I'm going to concatenate that with the rest of the string, also by slicing. So that's going to take the first position, or the 0th position, and all the way to the last position, but not including the last. I'm basically going to move the last character to the first spot in the string. So let's see if this actually worked. Okay, in order to test this, we need to run this function. Otherwise, it's going to get hard to keep track of what we're doing. So let's run it. Let's call Enigmalite. Okay, so let's see what we have. Let's print keys, and let's print values. Now, naturally, it'd be clever if we added the colon at the end. So let's try it again. There we go. So now we have two lists. The first one, rid of this, we don't need it. So the first one is the original list. The second one is the offset list. Okay, great. So that seems to work. Now we're going to create two dictionaries, one for encryption and one for decryption. So what do we call them? Let's call them dict.e for encryption. And how do we create that? Well, why don't we zip the values? So we'll zip keys and values. And then to create a dictionary out of them, we'll call dict. So there we go. And then we do exactly the same thing with the decryption dictionary, except we change the order of the key and value. So we'll say decrypt, and instead of keys values, we'll say it's the other way around. So we'll say values keys. So that's one way to do it. There's another way to do exactly the same thing, which we don't need here, but I'm showing it so that you can use it for other things. Or we can create one and then flip it by changing the dictionary so that the key becomes the value and the value becomes the key. So how do you do that? Well, do it this way. We can start by reusing this, and then we use something called dictionary comprehension to create the other one. So we say dict.d equals, and we're creating a dictionary. We say value colon key. This is the definition of the dictionary we want. Or e comma value in dict.e items. So as you see, what we're specifying is that we want to take the value first and then the key. So we want to create a new dictionary where the old value is now the key and the old key is now the value. And we take the key and the value from a dictionary that we have here, and the items spits out a list of tuples of that dictionary. So this accomplishes the same thing. It flips around the dictionary. All right, let's get some user input. First thing we want is the message. So the message is input. Enter your secret message quietly. There we go. And then we need a mode, our crypto mode. So what mode are we going to be running in? So input, crypto mode, either encode or decode. Encode will be E, or decode, which will be D. Okay, next step. Now we run encode or decode. Now we need a conditional. So let's do an if. If the mode is equal to E, then we're going to run the encode. So we'll create a new message, which is the encoded message. And how will we create that? Well, we use a comprehension, and we're going to be creating a list. So we'll say dict.e, and we'll call it letter, because we'll be typing letters, or letter, so for each one of the letters, in message. So this is going to use the dictionary E, and use the key letter, and then it's going to output the equivalent value for each letter in the message. And if it's not, so elif mode equals D, then we do the same thing with one small change. We change the dictionary E to be dictionary D. And then at the very end of the function, what do we always do? We return new message. Now let's go down to the Enigmalite, and then let's print the result of it, because now we're returning something. So what is that going to look like? Let's give it a shot. And again, sloppy with the colons. Sorry about that. So let's say hello, make it simple. Crypto mode, encode. It's now outputting, first of all, it's outputting our first two prints that we don't need, and then it's outputting a list. We don't really want that list. I'd like that in plain text. Okay, so let's comment out these two print statements and do something about these lists. So if we have a list and we want to create a string, what can we do? Well, we can join them, right? So let's join them on the empty string. And the second one on the empty string. Run this again. Hello. Crypto mode encrypt. Now we have a message as a string. And then if we want to get that string back, we copy it. We run the code again. And we paste in what we just copied, and we run the decrypt mode, and we get the message hello. So that seems to work. Now let's try and clean it up a bit, make it a bit nicer, make sure you can't mess it up as a human. So one thing we might want to do is when we're checking this letter here, let's make sure it's a lowercase letter we're checking, so nobody enters the wrong thing. Let's do the same thing here. And then the message, let's make sure that is lower as well. Otherwise it might not be in our dictionary because we only have small caps. So message lower there. And then the return message, how about we capitalize that? Now what else might we want to do? Well, I think that the conditional we have here is a bit long. Let's make decrypt the default, because a spy that needs to decrypt might be in more of a hurry. So we'll change that. And instead of saying elif here, we'll say else. So in all other cases that they're not trying to encrypt, we will run this statement. How about that? Try it again. Hello, all in large caps, and we'll start by encrypting. So we get this string. It's capitalized, looks good. Let's run it and decrypt, and we get hello back. So now that seems to work. And now to just prove to you that both of these work. So we've been obviously running these so far. So let's comment those out and make sure that this runs as well. Type a message, encrypt it. So there's your message. I suggest you copy that, paste it into the input box, and run decrypt and see what it says. I'll see you next time. So I think we've established by now that the best way to get good at programming is to practice. So let's practice with another project. We're going to create a math tutor that tutors us in multiplication tables. So the application is going to take input from the user and ask for how many questions they want. Then we're going to present the user with a question like 5 times 5, and then the user inputs the answer for each of the questions one by one. When all the questions are answered, we print out the following information: some form of greeting, like thanks for playing, number of correct answers and the total answers, and then the percentage that the user got correct. And you can use different rows as you feel like it. Remember that the \n and the triple quotes don't really work properly with Python. Then we have a couple of bonuses. We measure and present the time it took to answer the questions, all of them in total, and then per question. The per question should probably be on average, but you can do it by calculating the time for each one of them exactly as well if you want to. Let the user specify how high the tables should go. So should we be doing 5 tables, 10 times tables, or 15 times tables? Then show all the questions and answers at the end as the final bonus. And don't forget to save the work you're doing so that it just doesn't disappear when you turn me back on. All right? Okay, I'll see you in a bit. So how'd that go? I'm sure it went swimmingly and you have a fantastic math tutor in front of you. You've learned so much that I'm pretty sure that you've done some things that are much smarter than what I'm about to show you. But let's get cracking. So when we're building things, one of the first things we should often do is write something called pseudocode. And pseudocode is just basically English or your own language kind of description of what you want to do. Now, there aren't any real rules for how to do this that I'm aware of. The main part is to just make life easier for you. So I have a snippet here that I'm going to paste in of what I think I need to do. So I'm going to import some modules. I'm going to ask how many questions the user wants, set score and start at 0, loop through number of questions, create 2 random numbers and calculate the answer, show user the question, capture answer and modify user score, and then output the final score. And then basically I'm just going to fill in code in these spaces and see what we get. So import modules. Which one do we want? Well, I'm going to import random. And to make life easier, what I actually want is the rand range function. So I'm going to import from random, import rand range, and I'm going to call it R. That means instead of writing random.randrange each time, I can just call it R, which is much shorter. So great. So we've imported that. It's not as easy to understand and read, but let's not worry about that for now. Ask how many questions the user wants. That is going to be the number of questions. That's going to be an input. How many questions do you want? There we go. And of course, we want to make that an integer instead of a string. So we turn it into an int. There we go. Next thing, we need a score. So let's have a score. Score, and that gets 0 as the starting value. Then we want to loop through the questions. So we want some form of loop. So let's try a for loop. Let's call it Q for questions, and range, number of questions. Finish with a colon, indent. So what are we going to do there? Well, let's say num1 gets, and then we're going to use that super function we have, the R. So that's actually random.randrange. And the rand range picks a random number within a range. And I'm going to get a number between 1 and 11. Now that's actually going to give me a number between 1 and 10 because it's non-inclusive, so it doesn't include the 11. It only goes up to 10, right? Number 2. Number 2. Well, let's not make it difficult for ourselves. Let's just copy this one. There we go, exactly the same number, except it's going to be num2. Now there's a different way to write this that I'm going to use instead. I'm going to say this instead. So I'm going to define two variables, and then I'm going to define two values like this. That's exactly the same thing as writing it on two lines. So num1 gets that first expression, and num2 gets the second expression. Awesome, right? Then I'm going to define the answer. So ans is equal to num1 times num2. That's our answer. Then we're going to get the user answer. So let's call that uAns. And again, we're going to make a input into an integer. So input, we'll use an f string and we'll say num1, back that up, times num2 equals, and that's where the user will input the number that they think the answer is. So then we're going to check if he inputs the right number. So if uAns is equal to ans, then we're going to do something. What are we going to do? Well, we're going to increase the score. So score plus equals 1. And that should do it for our loop, shouldn't it? And at this stage, we want to print out the final number. So let's say print, thank you for playing. Now, if this was not Scrimba, I would say \n, which means a new row. You got, and then how many right did we get? Well, we got the score right. So score out of, how many questions did he have in total? Well, that was the number of questions. And then we're going to calculate the percentage. So that would be the score divided by the number of questions, right? Those are calculations, so we need to put those in curly brackets as well. Like that. That's also a variable, not a string. And then I'd like to round it, otherwise it's going to be a big number. So we'll say round, which is a math function. And since I don't have a comma here, it's just going to round it to 0 decimals. And then we want to multiply it by 100 to get it into percentage. Then we put a percentage sign, and that should do it. Let's try it. Turns out I forgot to close the string and also the print statement, which would be useful. So there we go. Now I have a pop-up box, and you should too if you try it on your own. So how many questions do I want? How about 2? 6 times 6 is 36, and then 10 times 2 is 20. All right. Thank you for playing. You got 2 out of 2, 100%. Let's actually encapsulate that answer a bit nicer. Let's put parentheses inside the print statement. There. Okay, so what was the next bonus we needed to do? Measure the time it took to answer questions in total and per question. So for that, we could import another module, the time module. So let's do that. From time, import time as t. Another one of those cryptic variables we're going to use in our code. And then we need to start the time at some point. So where do we start it? Well, let's start it before we go into the for loop. So down here. So let's call that start. So start gets t. So that's where we trigger that function, the time function. And then when are we going to stop it? Well, let's stop it when we're done with the loop. So down here. So end gets, we call the time function again. Now this is going to give us the difference in seconds between these two numbers if we calculate it properly. So let's add that to the string. Let's say after we're here, let's add some more stuff. Let's start by making this actually say that we got those correct and we got them in. And then again, we need, this is a variable inside our string. So, and we need to round the number probably. So round whatever end minus start to 1 decimal, so 5.6 seconds instead of just whole seconds. So this is the rounding function, and then that's the whole variable, so we'll close that. Seconds, and then let's specify the average time by calculating. So we'll put that inside of parentheses, and we'll say another variable, and that's going to be the end minus the start. So that's the total time, which we just calculated. So we're doing that twice. That could have been done more efficiently. And then we divide it by the number of questions. And then we're going to round all of that again to 1 decimal. So 1, and then you're wondering where's the round? Here's the round. And then seconds per question. Let's see if this runs then. So we run it again. We get a pop-up box. How many questions do we want? 2. 6 times 1 is 6. 2 times 7 is 14. Thank you for playing. You got 2 out of 2, 100% correct in 4.3 seconds. And then it seems like we've got the rounding wrong here on the last thing. Why is that? N minus start. Let's round the whole number. So we'll put parentheses around this as well. Run it again. You want 2 questions. 9 times 7, 63. 9 times 9, 81. All right. Thank you for playing. You got 2 out of 2, 100% correct in 6 seconds. 3 seconds per question. So that's kind of slow. So what's the last thing that we were going to do in the last bonus here? Bonus 2, let user specify how high the numbers used should be. Okay. So how do we specify that? Well, then we need to change this number right here. So we're going to let the user do that. So we'll use another input statement. We'll let him say the max number. And again, it's going to be a number. So whatever we get in the input box is going to be converted to an integer. So input is number used and practiced. Like that, and then we're going to use that max number in our code. So here, max num. But if we want to use the actual number, we need to increase it by 1, right? Because it's not inclusive. So max num plus 1 is the one we're going for. Okay, let's run that. How many questions do you want? I want 3 questions. Highest number used in practice. Well, let's say 5. 3 times 2 is 6. 5 times 1 is 5. 2 times 4 is 8. Now we see that thank you for playing. You got 3 out of 3, 100% correct in 7.4 seconds, 2.5 seconds per question. And that was only up to the 5 times table. So let's do the last one. Show all the questions and answers at the end. How do we go about doing that? Well, then we need to capture each one of them as they happen and then print them out at the end. So we're probably going to use a list and save them too. I think that sounds like a good idea. So let's go in here in the code and create a list. Let's call it answer list. So that's an empty list. And then we're going to start adding stuff to it. Where do we have all the numbers? So we're inside the for loop here, and here we're creating the numbers, here we're creating the answer, here's the user answer. So by here we have all the numbers that go into that. So here, let's put that inside the list. So let's say answer list. Then each time we go through here, we're going to append the data that we have for each one of the questions. So again, we'll do an f string, say num1 times num2 equals, and then we have the answer, and then whatever the user wrote, which is the uans. Okay, so we've created that list. So each time we run through it, if we have 10 questions, it's going to fill up with 10 ones of these strings inside that list. Okay, then we need to print it at the very end. So we need a new print statement, and we need to print on 5 rows. Let's say we have 5. So let's do a loop for printing. So then we can say for each one of the elements inside the list, we're going to print it. So for a random word in the answer list, we're going to print a. That should do it. Let's give it a shot and see what happens. So running the code. How many questions? Let's say 3. Highest number used in practice, 12. 2 times 2 is 4. 9 times 10 is 90. 5 times 10 is 50. There we go. So thank you for playing. You got 3 out of 3, 100% correct in 8.2 seconds, 2.7 seconds per question. 2 times 2 is 4. You got 4. 9 times 10 is 90. You 90. 5 times 10 is 50. You 50. We rule. Awesome. Okay. I hope you had fun. I'll talk to you again soon. All right then, in this project we are going to build a marble betting game, which is actually a trading simulator to teach people or new traders how to size their bets so they don't lose too much money. So this is how it works. We're going to have a bag with 10 marbles inside. So it's going to be a random draw. We don't see the marbles. There are 6 green, 4 red. Green is good, red is bad. If we draw a green marble, we win the same amount that we bet. If we draw a red one, we lose the amount that we bet. So if we had 1,000, bet 10, we now have 990. If we bet 10, had 1,000, and got a green one, we have 1,010. Marbles are replaced into the bag after each round, so the probabilities are the same for each draw. Before each draw, we decide how much we're going to bet and enter that amount. We start the game with 1,000 gold pieces, or dollars, pounds, or euros. The number of rounds draws should be variable. If we lose half or more of our money, the game is over and we lost. That's bad. Then we're going to print some data along the way to show the user how they're doing. Is it going well? Are they winning? Are they losing? And we should remember that when Scrimba is running, we can't actually print anything in the console. So everything we print out, we have to push out to the input box that pops up. You know, the one that you can't see when I'm running code, but you can see on your own machine? That's the one. And then as a bonus, we're going to replace 2 of the marbles, one green, one red. One of the green ones gets replaced with a black one that is a 10-time winner. So if we bet 10, we win 100. And the red one is going to be replaced by a white one, which is a 5-time loser. That's a terrible marble. So if you bet 100 and that one comes up, you lose 500. That's not a trade you want. And then one last thing before you get started, the index HTML. I've already uncommented the part here that allows you to import modules because you're going to need the random module, I'm guessing. So why don't you take a crack at that? And when I come back, I'm also going to talk about pseudocode and what that is and how to use that to write some code. So good luck, and I'll talk to you soon. So did you do that exercise? If you didn't, then go back and do it, and then come back and see me again. Okay, I'm waiting. Awesome. I'm sure that went great. So let's take a look at how to handle this. So pseudocode is sort of like writing English text that describes what we're going to do in the code and makes it easier for us to code. And to do that, first we maybe have to talk about what we're going to do. So we're going to have a bag with marbles, 10 marbles, 6 green, 4 red. We're going to draw a marble at a time, and first we're going to bet some amount that it's going to be a winner. And if we do that, we either win an amount or lose an amount. And then we're going to do that for a number of times, so that's probably a loop. And then at the end, we're going to print the final result. And if we lose half of our money, we lose the game. All right, so let's do some pseudocode here, see what that looks like. So we'll start with, I'm going to need the random thing. I'm actually not going to make that into code. I'm just going to say import random because we're going to need that. Then let's start writing some pseudocode. Then I need a bag. So create a bag with 10 marbles. After we've done that, we need some starting amount of money. So then we need whatever amount of money we have right now. So the current money. That's with wins or losses. Then we need the result of the last round. Or let's maybe do we need how many rounds we're going to play. We also need to know what the last marble was, because otherwise we can't calculate anything. So that's probably going to be a variable. Then why don't we welcome the user to the game? Then we're going to do our loop. So loop, drawing marbles. Inside the loop, we're going to do some stuff. We're going to find out how much was bet. Then we're going to draw a marble. We're going to figure out if it was a win or loss. Then we want to calculate win or loss or result. And probably our new amount of money and new amount, let's call it purse. How much we have in our purse from the medieval times. Then we lose the game, right? If we lose half our money, we lose the game. Then we need to print some results after each round, although that won't actually show in this version. It would in a normal version because of Scrimba and Python. Then we're done with the loop, I think. And then we need to print final result. Okay, so that's sort of my pseudocode. And then what we'll do is we'll fill this out and see if it works. And wherever it doesn't work, we'll try and fix it. So that's pseudocode. Let's give it a shot and see what happens. And of course, remember that whatever you wrote, as long as it works, that's fine. You don't have to do it the way I did. Maybe you have much better solutions. All right, so we create a bag with 10 marbles. Let's call it bag. Why make things more difficult than they have to be? Let's make it a tuple. So let's call one green. We could have called it 1 as well, and then we could have called the red ones -1, but this is more readable, so we'll do this. Comma, copy that. So we've got 1 green, 2, 3, 4, 5, 6, and 7. But the 7th one is going to be red, so we turn that into a red one. Copy that. 2, 3, 4. 1 comma too many. So that's our bag. Awesome. Starting amount of money. So let's call that the purse again, but let's call it start purse. And that gets 1,000 gold pieces. Woohoo, we're rich. Then how much money do we have now? Let's just call that our purse. And let's set it to the starting purse as a start value. Then the result of the last round. We don't know what that is yet, but we haven't played yet. So let's call it result. That gets 0. How many rounds are we going to play? Let's call it rounds. I recommend that you play this 25 or 50 times to make it fun. But for testing purposes, let's just play 3 to make it quick and see if it works or not. The last marble, why not just call that marble? And this time, we're just going to give it a string called none. That's not the data type none, that's just none as a string. Then we're going to welcome the user to the game. So that should be a print statement. What shall we say? Something interesting, that they start the game with some amount of gold pieces. So, and of course we need to enter a variable holding the gold pieces. So that would be purse, or actually starting purse. Start purse. There we go. Then we're going to loop. I'm thinking this is going to be a for loop, and we're going to do it for the number of rounds that we have. So let's say 4 and then some name. Let's call it draw. So we're going to do draws, right? So this is going to be one of the draws in range 1 up to and including rounds. But it's not inclusive, so we have to do +1. Go down here. So how much was bet? Well, that's an input, and let's call that bet. We haven't set that variable before, but we're doing it now. That's going to be an input. So input. So let's say their current purse, their last draw, and then whatever the round was, and ask them how much they want to bet. Sounds good. So let's say current, and then the variable purse. That's how much they have now. The last draw, let's tell them what that was. That was the marble, so that's going to give them a color. And then let's do a new line. That's \n. And then we'll say what round it is. And that we are going to get from the for loop. So that's our dummy variable called draw. So that's going to be 1, 2, and 3. Then we're going to say, how much do you want to bet? And what are we going to capture in an input? A string. Do we want a string? Of course not. We want an integer. So we're going to convert this whole thing, typecast it into a int. There we go. So what's next? Now we're going to draw the marble. So how do we draw something from a list, or a tuple in this case? We use the random choice method. So we'll say marble is going to get the value of random choice, and we're going to draw from the bag. Then we're going to figure out if it's a win or loss. And sure, you remember, green is good, red is bad. So let's do an if here and say if marble double equals green. That's good. We are going to get the result is the same as our bet. So there we go. And then in all other cases, it's going to be red. So this is our catch-all. So we'll just say else. So that's all other cases. The result is going to be bad. So it's going to be minus the bet. All right. Then we calculate the win or loss on our purse. So we take our present purse, and then we do plus equals, and then we add the result. If it was a win, we add bet. If it was a loss, we add minus bet. So that's plus minus, which becomes minus. So that's great. Then if we lose half our money, we lose the game. So we should check that each time we bet. So if purse drops below 0.5 times the start value of the purse, then we lose the game. So let's say you lost too much. And what else do we need to do? Well, anytime we lose, the game is over. So we got to break out of the loop. So we're going to break. And then after the code is run, so that we can keep track of what we've done, we want to print some stuff. So let's print some stuff that we want to keep track of. So let's print the current purse after each round. This is more or less what we printed in the input box, right? So we print the purse, the last result, put that in the parentheses, the marble, so that's going to be the color, and then how much we won or lost, so result. And then to space things out, let's do a empty line. If it wasn't Scrimba, we could just put a \n at the end of the first print statement. Then we're going to print the final results and calculate some stuff. So let's say starting ending purse. Let's print a little bit differently. Let's say start purse. So now I'm sort of not doing a formatted string anymore. I'm just printing using commas. And let's put in a slash and then the purse. I'm basically doing this to show that it's possible. It's not really best practice in any way, shape, or form. So print, let's say our gain and loss, and then we calculate how much money we made in percentages or lost. So what we're going to do is take our present purse minus our starting purse, and in parentheses, and if we do that and divide it by the starting purse, we will get the percentage return as 0 point something, but we want it as a percentage, so we'll multiply by 100, and we'll close that parentheses, and we'll put an extra there, make sure that it's proper, and then another comma, and then a percentage sign. Again, not really best practice here, just showing you that this is one way that you can print. And as far as I can see, with a bit of luck, this should run. Let's give it a shot. So I'm getting a pop-up box where it says current purse, last draw, marble. So we need to fix some stuff there. So 30, 40, and 50. So we get some printouts. That's nice. But there was something wrong in the input thing that we had. Let's see where that come from. Yes, this is not an F string. Let's make it an F string. There we go. All right. Other than that, seemed to have worked. So you can practice this, and we're going to do the bonus bit. So what actually happens in the bonus thing? We're going to replace two of the marbles, right? One of the green ones, one of the red ones. So let's replace one of the green ones with a black one. Now that's a 10-time winner. And then one of the red ones is going to be white, and that's a 5-time loser. That sucks. So we replace those. We're still drawing from the same bag, but now we can get black and white as well. So we need to go down here to this bit and make a change. So first we're going to check if it's green, and then else it's red, right? But now we have two more options. So what kind of if are we going to use here? We're going to use an elif. So if the marble double equals black, then we're going to create a new result. And the new result is not bet, but it's 10 times bet. Now that is awesome. And then we'll copy all this, do another elif, and we'll make that white. But this time, it's not 10 times, it's -5. Now that sucks a lot. We definitely don't want that one. So now we've modified the code to have those new marbles, and now I really recommend using this game to test. So let's give it a quick shot and see if it actually works. So I'm getting the pop-up box. You can run it as well and see what happens. Current purse, 1,000. Last draw, none. Round 1, how much do you want to bet? Let's bet 200. That's crazy much. Round 2, we actually made 10 times the money. That's insane. That's so lucky. It's ridiculous. So the next round, we're going to bet 200. We won another 200. So the next round, we're going to bet another 200. Wow. The fact that I made 10 times the money on the first bet is just insane. So that seemed to work. Now, one thing you can notice here is that this actually has a feature that makes it a bit like real trading. And that's the fact that if you enter a negative amount into the bet, that means that you make money when you get a losing trade or a losing marble. Now that's a bit interesting, and we could of course lock that away by only allowing positive bets. All right, I hope you found that interesting. I do hope you give it a shot and turn it up to 25 or 50 shots and see how you did. So I'll see you next time. Congratulations, you made it. You've finished the Python 101 course. You are truly awesome. Most people don't even start a course they have, let alone finish it, but you did. That is a real cause for celebration. Well done. If you still have some exercises to do, then just go back and do them. I can wait. When you started this course, you were probably new to programming, and a lot of this was probably a little strange and maybe even confusing, perhaps even frustrating at times. Think of how far you've come in such a short time. And frustration? Well, that's just life telling you that you're learning new things. For me, it's been a real privilege and joy to guide you through this course, and we've covered a lot of ground. You've learned how to manipulate strings, lists, tuples, sets, dictionaries, and iterables, immutables, and variables are no longer a mystery to you. You can control how your code runs with conditionals and loops. You can return values, comment your code like a champ, and control if the code will crash or play nice when something goes wrong, using things like try and except statements. You've learned how to create lists, dictionaries, and functions on the fly with comprehensions and lambdas. You've looked at the foundations of object-oriented programming, learning about objects, classes, and inheritance. And now you can imagine maybe how a doctor might inherit from a nurse. Together with the knowledge of modules and the knowledge that there's always many ways to solve a problem, hardly ever just one, you are now ready to set your sights on whatever you want to learn and just start doing it. Now, before I leave you to do more awesome things in your life, I have one last exercise for you. If you want to, you can close your eyes. Now, I want you to look and think back to the course for a moment and re-experience the part that was the very best for you. Think about what that was. Get it in your mind. Do you have it? Now imagine you're watching yourself in that moment on a huge screen in front of you, and you're experiencing the same emotions you did then when you felt awesome. See it. Really feel it. Feel the emotions you were feeling when you felt like that. Feel how strong you felt. Now turn up the color and the size of that picture so that it fills your whole mind. How does that make you feel? Now make it even bigger and double and triple the feelings you experienced, and bring those feelings back with you to right now and say to yourself, I did that. And you know what? Whatever comes next, I got this. And if you want to share your experiences and what you thought of the course, I'd love to hear from you. You can post in the Facebook group or tweet me. I'd really appreciate hearing back from you. For the future, I wish you the very best. Now go out there and make whatever your dream is a reality, because this code thing isn't a roadblock. It's a skill that you will master. So whatever it is you want, go out there and get it. And I look forward to hearing about your success. See you soon. All right, let's take a look at Project Euler, question 4. Find the largest palindrome that can be created by two 3-digit numbers that we multiply. And a palindrome number is a number that reads the same backwards and forwards, like 101 or 990,099. And we're going to look at two different solutions in this cast, and then in the next one we'll look at another one. And hopefully you can take away some experience on reframing problems and maybe how to work through solutions. All right, let's get cracking. So the first thing we're going to do is I thought we would make sure that we can import modules. So let's make sure this is active. There we go. And then we're going to time this and see how fast it is. So let's import the time. And then let's think through the problem. So we want to find all the palindrome numbers between 100 and 999. We want to find all the palindromes that can be created by 3-digit numbers from 100 to 999. So we need some kind of function to help us determine if a number is a palindrome or not. So let's create a function which we call isPalindrome. And we'll send that a value. And what we'll do is we'll see if val double equals val, and then let's slice it and look at the string backwards. Now that's great, except for the fact that we're taking in a value, and that value is going to be a number. So we need to do something. We can't slice a number. It would be nice if we could, but we can't. So let's say that val is now equal to the string of val. Now we can slice it. Colon there, and then to be explicit, we say that we return true if this is the case. And if it's not the case, so in all other cases, else we return false. Another way to write this would be that would return exactly the same thing. So the return statement is going to return whatever the value is after it. And an expression that is correct evaluates to true. And an expression that's incorrect evaluates to false. That would give us the same thing. You can try it if you want to. Now, so what we're going to do in our function is start with a brute force approach. So in this case, brute force means taking all of the 3-digit numbers and multiplying them by each other. So 101 by 100, 101 by 101, 101 by 102, and so on. And then after we've multiplied them for each number that we find, we're going to check with our function up here if it's a palindrome. And if it is, we're going to put it in a list and keep it. And then when we've gone through all of the different 3-digit number combinations, about 810,000 of them, we are going to see which is the biggest palindrome, and that's going to be our answer. So let's try it. Let's say def palindrome, that's our function. Then we need some variables. So first we're going to time it. So we'll say variable start time gets time.time. Our palindromes list starts as an empty list, a debug list. Our low val, which is going to start at 100. The high val, which is going to be 999. And then we're going to keep track of our iterations and start that at 0. Now we're going to do our first loop. So for all of the numbers up to 999, for all those, we're going to do the same thing with the second number. Now we're inside the core loop. So this is where we start counting our iterations to see how many combinations we actually tried. So we'll increase iterations by 1, then we'll have a debug line. And this might be a good place to test the code. In order to run this, we also have to call our function. If we run it up to 999, that's going to be a lot. So let's run it to 103, just to take a look at what the stepping looks like. So we see that the left number stays at 100, while the right number moves to 100, 101, 102. Then we go to 101 on the left number. And number 2 goes 100, 101, 102. And it steps through the whole case. And in this case, it wasn't that many iterations, but in our later case, they're going to be about 810,000, so that's a lot. Now we know that our stepping is working. We can turn off this. So let's check if the number that we have is a palindrome. So we now have, for instance, 100 times 100. And we're going to check if it's a palindrome. So we're multiplying the numbers and checking if the result is a palindrome. We'll get back a true or a false. So if we get back a true, let's do some stuff. Let's put the number in a list. And let's put some numbers in our debug list. Now that's just to keep track of what we're doing. There we go. So that's what we need to do. Then when we're done, let's print some values. So that's our palindromes list, our debug list. Then we'll print how many iterations we have. Then we want our largest palindrome. And the way we're going to get that is the biggest number in our palindromes list. So max. And then we're going to check how long it took to run, which is the current time minus the start time. And then we'll finish off with a spacer. So in order for this not to take all day, let's just do from 900 to 999. See what that gives us. And before we run it, let's make sure that our code is correct. So let's take a look. So here's a typo, debug, and down here we need a comma. So let's run that. So we get our list of palindromes. We've got the list first, then we've got our debug list, and then we have how many iterations we did. Largest palindrome was 906,609. It took 1.58 seconds. So we really need to do about 810,000 iterations. So by speedy calculations in my head, I'm going to say that's somewhere in the vicinity of 110 seconds. So let's say this run would take 110 seconds to complete. Now, the first way we can optimize this is to make sure that we're not multiplying all the numbers. So right now we're multiplying 105 times 106, but we're also multiplying 106 times 105. One way to get around that is to only run the loops until the numbers equal each other. So if we say if num1 double equals num2, then we'll break out of the loop. That way we should only run half as many. So now we're running 9,801. Let's try it with this new code. And look at that, we've cut the number of iterations by half and speeded it up to about twice the speed. So now it's only going to take about 55 seconds. So that's great, right? Now let's try and create something a little bit more nimble and clever. So we'll copy this because we're going to reuse almost all the code. Since we're looking for the biggest number and we're starting at the bottom, that's probably not the best approach. So let's start at the top and start searching backwards instead. So we start at 999 times 999, and then we start searching backwards. And as soon as we find a palindrome, we can hope that that's the biggest palindrome, but it might not be. There might actually be some other ones above it, depending on how we're stepping. Because if we're stepping down to 960, and then we're getting down with the other number to 960, and let's say that we find a palindrome there. Now it might be the case that if we go down to 959, if we multiply that by 999, that will give us a bigger number than 960 times 960, and it's potentially a palindrome, but we don't know about it yet. So how do we figure that out? So let's start by looking at what we're going to need. We'll do the same things, except we'll start at 900 here as well, and we're going to introduce a new variable, which we're going to call, and we'll set that to 900 as well. Now, we're going to be stepping backwards, and when we step backwards, we need to start with the high val. So the range is fine with us stepping backwards, we just have to put the numbers in the other direction. So now we have high val, low val, and then we have to say -1 to tell it that we're stepping backwards. Copy that, paste it in here as well, but we're going to use this secondary value, which so far is exactly the same as the normal low val. So we go down, if we find a palindrome, we put it in the palindromes list, and here's where we're going to do something different. We're going to introduce a ratcheted number. So this is a low number that we want to figure out is the lowest we need to go. And the way we figure that out is if we're stepping through this and we find a palindrome, again, let's say at 960. So number 1 is now 960. And we don't want to step all the way to 100. There's no benefit compared to the other method. We want to stop as soon as we get down to a number that there is no chance that that number can be bigger than the one we just found. So how do we figure that out? Well, if we just had 960 times 960, let's say, if we multiply those by each other and then divide them by the biggest number that we're ever going to use, which is 999, we are going to get the lowest number we need to go to be able to create a bigger number. That's not the best explanation. I hope you got it. But if you read the code that I'm about to write, maybe it'll make more sense. So low val equals the max val, num1 times num2, and then we divide it by the high val. And then we're going to compare that to our previous low val. And whichever one of those values is higher is the one we're going to use. Then we do our debug list again. And then in order to break out of the outer loop, we need to say something like if num1 is smaller than the low val, what do you think we're going to do? That's right. Then we'll break out of this loop as well and we'll be done. So let's try and run this code and see how that runs. But first, let's actually introduce some other numbers in our debug list. Let's take this number. Let's debug those. All right, so in order for this to run, we need to call it. So let's call it before the other one. Palindrome back. We got to name it palindrome back. Run the code again. So the first one, we've got our run code. Then on the second one, we've got our palindromes, we've got our debug list. And this third value is this number we calculated, 889.777. That's the lowest possible number that we go to in order to be able to get a number that's bigger than the one we have. It was currently set to 900, then it's 862, 900, then it gets 887, then it goes to 907, and then the second number also rises to 907. 4,278 iterations, and it took 0.7 seconds. So that seems to run. If we lower these numbers, so 100 and 100, we should still be fine. We'll run it, and we see that the results are the same. 4,278 iterations. So can we make this even better in some way? Yes, we can. We can also improve it by using this low num2 value. So we can say that each time we're here, we'll change that number as well. And we'll set it to num2 so that it will never need to go down as far. Put some debug lines of your own and try this out and see what the results are. So let's run that. Now we see that we're only running 3,587 iterations and 0.67 seconds. So compared to the 110 seconds, that's almost a 200 time improvement. So it's running at 200x at the moment. Now that's pretty impressive, I think. And in the next tutorial, we'll take a look at an even more efficient way to do this, but that's a bit more specialized. This will run for any numbers we throw at it. So if we want to run between 500 and 2,000, this code will work for that as well. There you go, and I'll talk to you next time. Alright, let's continue to see if we can make this palindrome solver even faster. So we tried the brute force approach with multiplying all the permutations of the 3-digit numbers, and then we went backwards from 999 to see if we could find the biggest palindrome. Both those worked, and one was a lot faster. Now we're going to try and make it even more speedy. And the way we're going to approach it is, instead of looking at the 3-digit numbers, we're going to look at the actual palindromes. So let's start with the palindrome 999,999, and then we'll step through all permutations of palindromes, since we're humans and we can figure out how to do that. And then when we find a palindrome, we'll check if it's divisible by one of the numbers in the predefined range, which we're going to calculate in a second. And let's do this, so that you can call this function and play around with it while I'm talking. So let's paste in some code so you don't have to watch me type the whole day. Right, so here's our palindrome create. So first we're going to create a list with all the strings that we're going to need to create the palindromes. Then we're going to use our iterator just to keep track of how many iterations we do so that we sort of have some idea of how long it takes. And then for the first digit in range up to 10, we are going to do something for the second digit, and then for the third. And then we're going to create the palindromes, and the way that we do that is we concatenate a string. So first we have the first string. So let's say we start at 999,000. So this one is a 9, this one is a 9, the third one is a 9. And then you see that we use the digit 3 again to make this palindrome. So for every number, we are creating a new palindrome. And the first time that we iterate through this, we're going to change the digit 3 here, and also this one. Those will go to 8 instead. And that keeps on happening. And then we're going to create our actual number. And we do that by taking the string and making an int out of it. And here's a debug line that you can use to uncomment to see what the actual palindromes are. Then, similar to our previous function, we're going to calculate that low value, which is when we find a palindrome, to figure out how low we actually need to search. So we're doing the exact same calculation. We're taking the number, the palindrome, dividing it by 999. We could also do a floor division, which is double divided by 999. Then we don't have to do the int casting, because that actually creates an int. Then we're going to create the highest possible value that we're going to search for. And we do that by taking the square root out of the palindrome, because if we take the square root out of something, and the number is, say, 950, then if one of those numbers is higher than 950, the other one has to be lower, which means that we would find it in our lower search, right? So after we've calculated those, we're now going to check if the palindrome is divisible by any of the numbers between minimum and maximum. So for each of the digits in the range, low val to high val, this is where we start counting our iterations. If the palindrome, modular or divided by the digit, double equals 0, this is a way to check for divisibility. So if we actually find a number that's divisible, that means that we are done. Then we're going to return some stuff from this function. The palindrome, the digit, the palindrome divided by the digit, so that will give us the second number, and then the number of iterations. So now I created this code to run the code in case you wanted to do it beforehand. Let's write a function that actually tests a couple of iterations. And the way we can do that is to say, first specify the number of runs we want to have. So let's say that we want 10. So that means we're going to run this code 10 times. I actually don't want to run this. Now we're going to do our timer here instead. So start gets time for run in range and then the runs. We'll create a return value and we'll return the function value to that. And then when we've done the function, we'll stop our timer. And at the end, we'll print the return value, and then we'll do the average runtime that we use. So we'll take the total time and divide it by runs. So end minus start and divide it by the number of runs. There we go, and we'll run that 10 times and see what the answer is. So there we see we got the answer right. The digits, 913, 993, we recognize those. 2,136 iterations is how many times we had to check. And the average runtime was 0.06 or 0.07 seconds. That's about 10 times faster than the last variant. All right, so that's awesome. So let's try another approach where we basically do the same thing, but we just structure it differently. So again, I'll paste the code and then I'll walk us through it. So this is the palindrome create number 2. We have our iterations, and this time we're going to be stepping through digits in a range. So it starts at 9, goes down to 2, and it should actually go down to 0 because we want the number 1. So it's not inclusive. And step backwards using the -1. So we do the same thing again. Then we create the palindromes by adding the place values. So we'll step to 999999, and then we'll step to 998899, then 997799. It's the same thing we did before, except now we're going to calculate it instead of just put together a string. So the palindrome, we take the first digit, multiply it by 100,000, the second one by 10,000, third one by 1,000, then 100, then 10, and then the last one is just the number. And then we have our debug line again, if we want to look at that. This time we're actually getting a number, right? So it's not a string, so we don't have to typecast it. Then we do the same calculation with the low val. Again, we could use the floor division. We do the high val calculation exactly the same way, and we do exactly the same thing underneath this. So the only difference is that we're using this calculation here in the hope that it's going to be a bit faster. And to make it more exciting, we're going to change the function call as well. So now we're going to dynamically call both of these functions from our code. And I thought that would be nice to show. So we can say for func, for function, in, then we'll do a list of our actual names, right? So we'll call it palindrome create and palindrome create 2. And we take all this code, indent it, because we're now inside another for loop. And in order to call these functions dynamically, we only really need one new thing that we haven't talked about before. And that is the return value. How do we call a function by its name if we only have it as a string? Well, we've got it up here as a string called func. So the way we can say that is we can say locals. So that looks through the local variables that we have in functions. And then in bracket notation, we'll say func. So that's the name we're looking for. And then we end it with the brackets, because that's how you do a function call. Now, in order to debug what this looks like, we could say, you can take a look at that if you want to. So what this should now do is first call palindrome create 10 times, and then palindrome create 2 10 times. And then at the end, it should print each one of them. So let's see how we do on this. And once again, I'm beaten by the colons. So let's try it again. There we go. So now we see that that was a bit faster. So if we take a look at the evolution of our code, we find that our first method took about 110 seconds. So that's what we're going to call 1x. The second one, when we have the search space, is 2x, or 55 seconds. Then when we stepped backwards, it was 0.6 seconds, or 150 to 180 time improvement. And now, when we've done this very specialized code, it's gone down to 0.06 seconds. So that's between a 1500 and 1800 time improvement. I think that's pretty impressive. So I hope you enjoyed that, and that you try some of your own ideas and see if you can make this even faster or do it in a different way. And I'll speak to you next time.